Hello and welcome everyone to another episode of the WeAreDevelopers Live Days. My name is Bene and I'm here at the WeAreDevelopers headquarters in Vienna, and I'm happy that you all made it today. So before we start with today's topic, which is cloud, quick reminder for our regular viewers and as an info for our newcomers. Code 100, our coding competition, is back. Its next stop will be Manchester on May the 22nd this year, of course. So if you happen to be around in the area, make sure to check your free ticket on code100.dev, or if you think you're up for the competition, then make sure to apply as a challenge and maybe you will be our next local champion. So, and now before we start with the first talk of the day, quick reminder, you can interact in the chat to your right. Submit some questions. If you got any, the speakers will gladly answer them after their talk. But during these actions, keep in mind, please be nice to each other and respect each other as you have a code of conduct. Here's a short video about it. And now let's kick off Cloud Day with the first talk and the first two speakers of the day. Yeah, we got two people from AWS. One is Senior Solutions Architect there and the other Senior Customer Solutions Manager. So they certainly know what they're talking about when it comes to cloud. Very welcome, Robert and Christian.
Hello. Good morning.
Thanks so much for joining. Good morning, you two. So, cool that you are here, but before we start with the topic, I already said you work at AWS and that you have positions in which you, of course, know what you're talking about. But what will you be talking about? What's your topic?
Yeah, so in general, there's currently a lot of hype about platform engineering and developer platforms, right? So everybody has one or builds one. And we see a lot of customers who just want to become better at building those platforms, building the right platforms for their developers. And that's essentially what our talk is about today.
And I will then add a few sentences about developer productivity in general and how you should measure and increase it, and cover a few case studies and latest research about it.
And there will be some cool demos. So stay tuned for that.
Always love to see some demos. Hey guys, that sounds like the perfect topic to kick off Cloud Day. So without stealing any more of your talking time, I would say the stage is all yours.
All right, let's dive right in. So today we're talking about how you should forget platform engineering and rather think about developer productivity. And what we really mean by that is when you're building platforms for developers, a lot of customers are looking for a more customer-centric approach to building them. And the customer in that case is, of course, the developer. So what's the gist of the talk you're seeing today? Well, we are asking you to not lose yourself in the traditional way of building platforms, which often means running a lot of systems on your own, running a lot of infrastructure, keeping this up day and night, and really losing a little bit of sight of what's really important, and that's developer productivity. Instead, we want you to really compose and integrate ready-made services so that you keep your head clear for really thinking about your developers. And in the second part of my talk today, we're talking about how you can actually do that. So we will give you some frameworks, some thoughts about how you can think about developer productivity, and then work backwards, as we like to call it at Amazon, from your customers, the developers, to create the right developer platform just for them. But before we really dive into it, let me give you some context. Let me go back in time so we can think about where it all started. In 2006, Werner Vogels, the CTO of Amazon, he had this catchphrase, and he said that when he was talking about what's a good way for product teams to build digital products, and what's a good way for those teams to work and operate. And he said, well, a good way to do it is you build it, you run it. So the idea is that developers really should be in contact with the day-to-day operations of their software. And he really sees this as a critical feedback loop for improving the quality of a service. And also around that time, maybe a few years later, this whole idea of DevOps started to emerge, right? So we were thinking about how can we move operations and development closer together. So all in all, great ideas. But fast forward to today, there's a little issue here, and you can see it here. It's actually quite a big issue if you open the page. So I don't want to throw the CNCF landscape under the bus here, but the idea is basically there's a lot of cognitive load that a developer has to deal with today, right? There's lots of services, and you do not even just have to think about how to code your service, build your service. You also have to think about delivering it to production, adding observability, dealing with containers, and all these kinds of things. So that's actually where platform engineering tries to come in and tries to reduce that cognitive load for the developer and make them more self-sufficient, make them more autonomous. And another way to say that, and I like this quote a lot from ThoughtWorks, is that platforms, for example, developer platforms, are a means of centralizing expertise while decentralizing innovation to the customer or user. So that's great, right? We can build a platform that helps developers make their lives easier and get their code on the infrastructure and so on. If you want to think about how this could actually look like, again, I'm pulling from the CNCF here. This is like a very high-level overview of how such a developer platform could look like. And you might have seen this picture or other pictures. There's lots of pictures that are almost all the same. And you can see essentially that in the middle, there's a bunch of platform capabilities that you want to offer to your developers. So, of course, you need compute, networking, a database, messaging queues, identity management, these kinds of things. And then on top of that, you want to provide some interfaces. So ways to make the platform more accessible to users, like documentation, templates, maybe a CLI to put those services together. So again, great idea, great concept, makes a lot of sense. But there's still a challenge here. And that's you can actually spend a lot of time building this out, right? There's lots of boxes essentially for you to check. I need all those services. And in some sense, you can lose yourself in building the perfect platform. And this is something that we sometimes see with customers and their platform teams, is that they have a very technical view. They are really great at building those things, but there's a slight risk of over-indexing on building this textbook platform instead of focusing on what your developers really need. And sometimes you spot those signs that maybe the platform team could kind of course correct a little bit. So what are these kinds of signs that we might see? That's what I like to call the downward spiral of platform engineering. And the essence of it is running too much and the wrong things that actually developers do not really like or do not really use. To go a little bit into the details here, it all starts with step one, which is prioritizing the wrong work streams and features. And then it's often followed up by reinventing the wheel and building undifferentiated services. And these two things often happen because you're not close enough to your user, to your customer, which is the developer. So you're not gathering enough signals, enough data about, okay, what's actually the biggest friction point for my developers? What's actually their problem? What is holding them up during the day? And instead, you're really focusing on these building out these really big enabling services that might not necessarily be what the developer needs right now. So if you're down that path, often there's another problem that arises. And that's, now you have built all these services, these platform services, maybe even on top of cloud. And now you're spending most of your resources, most of your capacity, most of your team time on operating those services. And that can be very frustrating for platform teams because they feel like developers are asking them for things all the time. Hey, can you add this? Can you do that? But they feel already super busy with just keeping the services running that they already have. So they are kind of have tied up all their capacity in just keeping the lights on, essentially. So typically, you can find that if you're doing things like running Kubernetes clusters or running Kafka clusters on your own, there might be reasons why you want to do this. If you do something very specific, if it's like a differentiating service for you for whatever reason, or if you're doing something that's very industry specific. But for a lot of customers, it's really a commodity service, and there's not too much value in running these services. Moving further down the spiral from there, now you have all those services, and there's another problem coming up, which is the developers, the platform teams, they really feel now that their identity is tied to the services, right? It's the Kubernetes team, it's the Kafka team. So for those teams, this is their reason of being, and that can make it really hard to change these services, maybe deprecate them, switch them out against another service, because the team thinks like, hey, this is my foundation. That's why I'm here, basically. So we have like interesting discussions where engineering leaders of customers are even like, maybe I should call my Kubernetes team actually compute team. That would make their job description a little bit broader, and they would feel like there's more to do than just running Kubernetes. So again, this can actually make it hard to be a nimble platform engineering team, and really also improve things when you want to switch out a service. There's another fallacy that comes up sometimes, and that's actually you are believing you're good at building abstractions. So, essentially, if you think about programming, we have abstractions like classes that try to abstract away certain details of the implementation. But when it all fails, you still get the full stack trace, right? And you can see down the guts of the program. and you're like, oh, that's what's actually going on under the hood. And platform engineering is similar in some of those aspects, right? There's a lot of talks about, hey, we're doing platform engineering to reduce cognitive load, to abstract infrastructure and whatnot. But building good abstractions is actually really, really hard. And one reason why it's really hard is that oftentimes when people think about abstractions, they're thinking about just the template, just the configuration time abstraction. Oh, I just put together a template, it does these things, it adds these services, and then it's done. But the problem can often start when actually this stuff is running in production and something breaks, and then the developer opens up the Kubernetes UI, the console, the CLI, and they see all those guts that they have never seen before. And now they feel like, oh, I actually don't know how this works. So this is why looking at cloud services that try to abstract things away at configuration time and runtime, for example, things like serverless, can really be a big bonus here. And it's sometimes actually overlooked that runtime abstraction is super important to be productive as a developer. Now, up to this point, in our fictional misery story, we made a lot of mistakes. And to basically lock us in our mistakes, one thing that can happen is that you kind of create your own echo chamber as a platform engineering team, which means you are measuring things, you're asking people for feedback, but you do not do it in a very broad way. Instead, you're really asking about, hey, I got this service, I got Kubernetes, I got Kafka. Do you like these services? Yeah, great. Okay, then I move on. And you're not really leaving room to ask, hey, let's leave aside the services we have today. Just tell me about your workday. What's really nagging you? What feels like it takes a lot of time? What feels like very hard to do? And it's really important to get this feedback as well, to work backwards from your customer, as we say. Now, summing up all these problems, all of this downward spiral, Charity Mayers, who's the CTO at Honeycomb, I think she framed it really nice in one of her recent talks, which you see on the bottom right, perils, pitfalls and pratfalls of platform engineering. Can definitely recommend checking out that talk as well. And she said it very nicely. She said, well, you have a platform engineering org which wraps and packages your infrastructure needs by running as little infra as possible, right? And that was exactly the problem we saw in the downward spiral. A lot of stuff happened because we were over-indexing on running infrastructure on our own and not leaving enough space to actually go to our developers, ask them what their problems are, and basically replacing platform engineering with the idea of, hey, in the end, we just want to improve developer productivity. And that brings us to the beginning of the talk, brings us back there. So we said, hey, we want to spend the resources on the right things, and we want to think about developer productivity first and work backwards from our developers who want to be more productive. And now I'm saying, well, it's super nice buzzword, right? Developer productivity. But how can I actually do that? I have no clue. And I didn't have a clue either. But a lot of other smart people had a clue, and they wrote a paper about it. And their answer is the DevX framework. So what is the DevX framework? It's a framework for a more customer-centric approach to improving developer productivity. And it's actually brought to you by the team that invented also the other very well-known frameworks in that area. So you probably know Dora, you might know Space. These are the same people. And this is basically the next chapter of their research and thinking about how you can make developers more productive, how you can measure it, and how you can get good feedback. And essentially, they're saying developer productivity is very much expressed through developer experience. And we are modeling developer experience in 3 core dimensions that you see here on the right side, which are feedback loops, cognitive load, and flow state. And these things really help you to now model the developer, let's say, as a more complex being that really has those needs to be productive. And if we go through the separate points here, essentially you have the feedback loops, and you can probably guess what that's about. So when a developer makes a change, is the feedback fast? Do they have the right tools, the right observability to get feedback very fast in their CI/CD pipelines? And then you have the cognitive load. So that's what we already talked about a little bit. And it's typically where, platform engineering tries to break in. So how much stuff do developers need to keep track of in order to complete a task, to build a service, to deliver it, to run it in production? And finally, the third one is flow state. And that's really about how easily and how often are you able to get into that zone where you are super productive, laser focused on writing your service and bringing new features to your end customers. What I really like about this framework is that, again, it's very user-centric, right? We're trying to get a deeper understanding of our customer, which for the platform engineering team is the developer. And it's putting the developer really at the center here with a more comprehensive, more holistic description of how a developer works, right? How they function, what is important to them. And speaking about working backwards from customers, that's really something we love to do at Amazon. Jeff Bezos, our founder, famously said that being customer centric is a great approach, because one of the biggest benefits is that customers are always dissatisfied, even if they are reporting that they're happy. And so there, the DevOps framework really hits home for me, because it gives us tools to zoom in on a very specific customer, the developer. And it helps us to understand more this specific customer type. And it helps us to ask the right question. Talking a little bit more about working backwards, this is like a general process we have at Amazon that you can use for almost anything to build a product that delights customers. And it typically starts with asking 5 customer questions that you see here on the left. So who's the customer? What's their main problem? What is the solution and the most important benefit? How can we describe it to the customer? And how we can test it and measure success. And for all those questions, right, the DevOps framework can really help us to ask the right questions, and how that looks like we will see just on the next slide. And then if we go further in the working backwards process, what we typically do is we write a press release. So it's like a fictional release of the service where you write down, how your developers are delighted with X feature or way to build services, to release services. And also we typically attach like super scrappy visual, so you can, scribble down something, how it looks for developers. Maybe there's a portal, maybe there's a CLI, maybe not. And we also write an FAQ to add even more details, typically hard questions like, okay, what is it really about? Cut the marketing talk. What is it really? What is it not? What is missing? And so on. And then with this fictional product announcement, we put ourselves in the shoes of the customer or the developer in that case. And from there, we can go on and actually build out a prototype and then scale that. Now, we said that this working backwards process can be applied to anything. So it's like very generic. And now we want to do this specifically for platform engineering for our developers. So how can we do it? Well, we take the DevOps framework and we use that to refine how we approach the working backwards. So in the DevOps framework, and again, that's from the paper, there's multiple layers in which you basically find out how your developers are feeling right now and what could be improved. In general, there's one dimension, which are the three things we talked about before. So the feedback loops, the cognitive load, and the flow state. And then it goes into multiple layers to dive deeper. So the first layer is really getting the perceptions of your developers. There you ask things like, for example, for feedback loops, hey, how satisfied are you with, checking out code, making a change, running the tests, and so on. For cognitive load, you might ask, hey, how easy is it for you to debug a production system? And then if you go to flow state, you might ask, hey, do you feel like you can regularly go into flow state? How long can you go into flow state? And so on. And this is really how you kick off this working backwards process, because you can do this as a survey, maybe company-wide, maybe per team, but you can also use this as a blueprint for an interview. So you might, so we're at Amazon, we're really fond of just talking to customers. And we've seen that, even talking to a few developers, some selected developers in your company can already yield great results in getting an idea of, what are the common problems? Where do they need help? What do they want to rant about? Essentially, that's what you want to know. So you can either do this as a survey and or as an interview. And this is how it all starts. But from there are like even two more layers. So one is the workflow layer. And there, again, in the 3 dimensions, we're trying to get more objective metrics on the whole thing. So you see some examples here, like, for example, for feedback loops, you want to see like how much time does it take to run the CI pipeline, or what's the code review turnaround time. So these are more hard metrics. You can ask them from developers and basically ask for an estimation, but you can also collect those metrics really from your system by instrumenting it, by creating a report. And the way to use that workflow section here is really to ground, to base the input you got in the perception row. So the idea is here, maybe developers are telling you, well, in perceptions, developers are telling you, yeah, everything's great. But if you look at the actual metrics of the workflows, you're seeing that, oh, actually, at least from the outside, it looks like this could be much faster. We could deliver software much quicker. So at least it gives me a pointer to say, hey, maybe I want to dig a little bit more into that with the developer next time and figure out, hey, how do they feel about this taking X amount of hours? Do they think this could be faster? And this is a trend or a theme with all of those layers, is that you do not just do one of them. You need to do all of them together. Otherwise, it's not working. Because you need a lot of context to actually understand things, right? If you just would do the workflow part, where also in the workflow part you could imagine to put your DORA metrics there, it's great as a high-level metric, but without the perception part, you're still not sure if you have the context, right? So if a DORA metric is telling you, oh, this is very slow to release, maybe there's a reason for that. And that reason you only get to know if you also do the perception part of the framework and actually ask developers, hey, why is that slow? Or do you actually feel that is slow? That is holding you back, or is it just fine? And finally, to top it all off, there's this KPI dimension. And the idea of the KPI dimension is just that you want to have a metric for the overall perceived ease of delivering software. So you want to have some metric that shows you that with all the changes you are making based on the data you collected in the other areas, overall you're actually moving in the right direction, that things improve. So you can ask things about employee engagement and satisfaction, or their perceived productivity. And in general, you want to see that this metric at least not going down, but ideally it should be going up. It's not a hard target, like you're not saying, oh, I want this KPI to be X, but it's more about, a general guideline for you to see, oh, yeah, things are actually improving. I did something here and there, and I added this service, and in general, people still feel like it's improving. If it's going down, you need to wonder, like, okay, maybe I made things worse for some reason, and I need to dig deeper into that. So summing this all up, how could this working backwards process from your developers look like? So in the general process for working backwards, we have these multiple phases, like listen, define, invent, refine, test, and iterate. And coming back to the DevOps framework, in the very beginning, right, you together with like a core group of people at your company, you really study a little bit more about developer productivity and experience. So for example, you take a deep look at the paper I just mentioned, and you basically line that, hey, actually our core mission is to improve developer experience. That's the main thing. It's not implementing Kubernetes, it's improving developer experience, because that will lead to better developer productivity. And from there, you go into the listen phase. So you're asking, okay, who are actually my developers? What are they doing all day? And developers is a very high level term. It's like can be very different depending on your industry, depending on the use case. And what insights do we have about them? And this is really where you can already start applying the DevOps framework with the questions we just saw. And it's not just about the questions we saw on the last slide. These are just examples, but you can also come up with your own ones. The rule is just that you need to cover all the 3 dimensions we talked about. So feedback loops, cognitive load, and flow state. So you would ask about that. And from there, you would figure out like, okay, what are the trends? What do I see from surveys or from the interviews I'm doing? What is like the prevailing developer productivity impediment that I want to attack, basically? And what could be a good solution? And what's the biggest benefit of that solution? And when you refine it, you can go back to your developers. So that's really important. Say, hey, you told us this stuff. We have an idea how we want to solve it, what we want to give to you to make it easier. What do you think about that? And if at this point your customer is still saying, yes, that sounds great, that's exactly what we want, you can start in testing and iterating on that to see like, okay, is it actually working? Let's build a prototype. Let's have a hands-on session together with the developers. They try it out. They tell us if they like the template, if they like the feature, the service, the UI. And from there, you can, further go on and take that minimal lovable product you just prototyped and really scale it out as a platform for your whole company. So to sum it up, we want you to spend resources on the right things. We want platform engineering teams to spend resources on the right things. The community sees that thinking about developer productivity first and foremost is a really great way to do that. You can combine that with a working backwards approach I just showed you. So really putting the developer as the customer in the center and asking about their problems and friction points. And the DevOps framework is one good way to actually frame what a developer is, how they work, and finding those productivity gaps. And this can lead to a number of improvements. So for once, platform teams might actually figure out that, hey, improving developer experience, that's actually my core identity. My core identity is not X service or Y service. It's actually improving developer experience. And that helps me to, broaden my viewpoint, consider new solutions, consider more scrappy solutions, not going overboard with like cool tech that maybe developers do not necessarily need. And when opening up those different solutions, you can actually find that some of them might be like super simple. So it could be just a wiki page because you figure out, hey, developers really just need a few bullet points on how to get started. They just need a bunch of infrastructure as code templates, because actually from cloud, we get a lot of services already. So they just need some good templates that we build from them. Maybe we want to collaborate on these templates. And maybe also, and that's the greatest point here, by running less services, your platform engineering teams get more headspace to actually think about all the new ways on how to improve developer productivity. And one of them is, of course, Gen AI companions, which is like a whole new category of things you can do to help developers. And to make that point very clear, that getting more headspace for new solutions like Gen AI is important, I will now hand over to Christian, and he will give you a glimpse into the future of those Gen AI companions. And we will show like why platform teams and developers should really take a close look at them. So handing over to Christian, please take it away.
Thank you very much. Yes, this part of the talk will concentrate on how to unlock the next productivity frontier with generative AI. This is quite a bold statement, so let's look at some data points first. That's a McKinsey study, and McKinsey tried to estimate the global annual Gen AI impact here. And what you can see is that 75% of the estimated global annual Gen AI impact actually stems from just 4 functions, and they are marketing and sales, product and R&D, customer operations, and software engineering. And software engineering really sticks out to me. If you add those 2 data points up, you will end up at roughly 900 billion global annual Gen AI impact. That's quite a lot, and this is majorly driven by productivity. So, but before we go there, how to actually measure productivity? Robert already discussed it very briefly. I will go a little bit deeper. So the most popular metric is, or framework actually, is DORA. And this focuses on change lead time, change failure rate, time to recover a service, and deployment frequency. A more recent one is SPACE. And SPACE is recognizing that development actually is a very socio-technological process. And they added metrics, especially in the area of satisfaction and well-being, communication and collaboration, and efficiency and flow. The most recent one, the most recent framework, is developer experience, which Robert also mentioned. And the dimensions they are closely looking at is feedback loops. They want to shorten feedback loops. They want to reduce the cognitive load, and they want to increase the flow state. So Gen AI will change a lot of what and especially how we measure productivity. Thinking about activity and output-based metrics, they will get even less useful in the future. But the mental model, especially behind SPACE and DevOps, this will hold true also in the future. If you increase the flow time, if you reduce the cognitive load, and if you shorten feedback loops, you will eventually increase developer experience and productivity. So to sum it up, basically, there is no single dimension to capture productivity. You will need to look at multiple dimensions. And it's also not enough to just look at quantitative data from your telemetry. You also have to interact with your user base, your developers, maybe with surveys. So always combine quantitative and qualitative data. And a recent research paper around developer experience actually found that developer experience might actually be the best proxy metric when you want to measure developer productivity. So, but how do we increase developer experience, right? How do we do that? And there is a study from Harvard Business Review, which basically says employees, and this is not only developers, this is all employees, are much more engaged and much more likely to stay beyond 3 years if they have the right technology supporting their work. So the right technology can mean a lot, right? This can be tools, this can be platform, and can be Gen AI. And another McKinsey study showed that Gen AI can really improve developer experience. This study basically shows developers are significantly more happy. They are more focusing on meaningful and satisfying work. and they're more often and longer in the flow state. And thinking again about developer experience, this is exactly what you want, right? But enough of all those studies. Let's check a use case now. And the use case, I guess everybody knows, is coding companions. They transform natural language to multiple code suggestions, right? Full function blocks. They do match your developer style. They hopefully know your internal code base, so your internal methods, libraries, to be actually able to be very useful, also based on your internal code bases and knowledge. They do security scanning and open source reference tracking. So that's great. My observation, however, is that the adoption rate, especially in enterprises, large enterprises, is very low. I couldn't find any data points, any study for that. But if you would ask me to guesstimate, I would say it's less than 20%. And this is actually something I would like to ask you. Like, if you're working in a large enterprise, is your company really adopting coding companions at a large scale already? So I would really be interested in that. Maybe let's cover that in the Q&A. The good thing is, if the adoption rate is low, then there's a lot of potential to actually improve developer experience. And how can you do that? Like, by using a coding companion, and just a few weeks will not help. You need time to get used to a tool. But eventually, you will end up being more likely to complete a task successfully, and you will do so on an average more than 50% faster. Thinking about space and DevOps again, there must be more to it. And yes, there is. Developers do feel more productive. They spend less time searching, they're longer in the flow, and this overall leads to a higher job satisfaction. So that was coding companions, and that's great. But developers are on average just coding 4 hours and 21 minutes. And that's per week. That's not per day. That's actually just 52 minutes per day. I was diving a little bit deeper in that study from software.com, and it basically shows that 90% of all developers are coding less than 2 hours and 10 minutes per day. Well, first, this sounds somewhat odd. It does make sense, right? Development is much more than coding. And now, and I promise, this is the last study I'm going to show, a Gartner study that shows 73% of all time, developers are actually running and maintaining applications and not focusing on innovation and transformation. Again, this sounds a bit odd at the beginning, same like this 52 minutes, but if you think about it, it does make sense. Let's briefly walk through an example. Let's say you build an app using your favorite coding companion. You did so, and you're running that app now on a Kubernetes cluster of your platform team. Everything is great until you run into an error. Something is not working anymore. So the first thing you will have to do is to learn about the issue and to understand it. You will dive into logs, you will digest all the metrics. You will likely need to interface with your platform team because you get, right, the whole error message. Maybe you will even have to learn Kubernetes yourself. So the abstraction the platform team broke, and now you need to dive into Kubernetes, which you actually wanted to prevent. Then you need to design a solution, decide for it. Then you write the changes, the actually coding part. You do the pull request, review. Maybe you update your observability and monitoring tools. Then you deploy the fix into production. Maybe that was not the first time. Maybe that happened multiple times, and you decide you actually want to move off Kubernetes and like have all the accountability and all the influence in your team. So you want to go to full serverless. And that's a great idea, but the cycle of development starts again, right? You first need to understand and learn about the technology, design an architecture, decide for it, develop, review, monitoring, and test, and maintain it. So the question is, if it's not coding companions, what do I need to flip that equation, to actually give the developers more time for innovation and transformation and not for running and maintaining apps? And the answer is, what you need is actually, it's a development companion, so much more than a coding companion. The development companion shall help you across the whole software development lifecycle, understanding and learning, deciding and designing, developing, reviewing, monitoring, testing, and maintaining. So if you go through that basically step by step, let's start with understand and learn. What you will likely do, let's say you're new to a company, new to a team, you have new responsibilities. Maybe you want to develop a new feature. First thing always is understanding and learning, right? Non-functional and functional requirements, what's the existing environment. So you will dive in documentation, and then you will decide and design for an architecture. And there's actually a cool concept by DevOps, and that is called knowledge discovery efficiency, or in short, KDE. So the KDE is a value, like a number between 0 and 100. And it's calculated for each developer individually, and basically signifies the knowledge the developer lacks or doesn't lack to complete a task. So when the KDE approaches 0, there's a lot of information missing. You'll need a lot of research. Maybe you need to learn new languages, tools, frameworks. This induces high cognitive load, and this is not what we want for productivity, right? When the KDE value approaches 100, this signifies a solution where there's basically no information gap. Everything is well known. And I hope some of you guys know Star Trek. There's this guy Q, almighty and all-knowing. And like he will be like one of the few persons having a KDE score of 100. And why I'm saying that, the question is, can GenAI help us to build an all-knowing Q, an all-knowing entity, which we can simply interact with, which we can like ask the questions so that we don't have to search ourselves and do all that work? So is there a solution to increase the KDE value for us? And yes, there is a solution. GenAI can help you with that. Let's say you want to first understand the existing app requirements, use cases, and you know everything is well documented, right? Somewhere, but where? And this is, by the way, the reason why they call it search engine, not find engine. It will keep you searching. And a potential solution is just ask your all-knowing development companion to give you an overview about the app. And why does it know? It knows all your internal documentation. There are a lot of plugins, so it's very easy to integrate Atlassian toolset, web scrapers, GitHub, GitLab, whatever you need, wherever your data points or your data is, to get an understanding. Maybe the next step is you want to not only understand all the use cases, but maybe you want to add a piece of functionality. And for this, you will start with a user story. User story require technical knowledge, right? How is the app built? What would I need to change to actually do it? The development companion knows your environment, can do so. And in this case, I can even ask it, hey, cool, I like that user story. Please give me a Jira task for that. And you can do that. And with this, the development companion really help you from understanding until writing a user story based on your internal documentation. And this is increasing your knowledge discovery efficiency, right? It's shortening feedback loops and reducing your cognitive load. So there we go. And the next step is you likely want to design an architecture and decide for it. But maybe you don't know if the services you want to use are allow listed. So what you should not do is shoot an email to the CCOE, right? Long feedback time, like you don't want long feedback loops. Simply ask your development companion if those services are allow listed. And there we go with the answer. 2 of them are allowed, 1 is not. So why does the development companion know? Again, it knows your internal documentation and it knows your service control policy. So the next step would likely be, I want to add the missing service to the allow list. And there I get a step-by-step manual on whom do I need to contact, with which information to actually get the service allow listed. This is shortening the feedback loops and overall increasing your productivity. The next step in the software development lifecycle then is develop and to review. Again, it starts with understanding. There's always understanding involved. And also there, your development companion can help you. You can simply ask him, what does my code here actually do, right? Hopefully it's not your own code and you need to ask him. I heard that happening too. But maybe it's like an existing code base and you're in a new project. And you can ask it, hey, help me, what is the code actually doing? How does it work? Maybe it's a language you don't know yet, or you're not very good at, or still learning. And there you go, right? This is an answer. Also explain, okay, why is UUID used and for what is it used? And the development companion really knows your environment. So you can even suggest improvements, or you can ask it, hey, how to best deploy it in a serverless way. If you want to add test cases, and you should always aim for higher test coverage, right? It can help you with that. But maybe you really want to go way beyond that and even develop a whole feature. You have that code base, right? And you want to add a piece of functionality. You can ask your development companion, hey, please implement an add product function. And as it knows your environment and your internal documentation, it can do so. The first step will be you will get a step-by-step approach on what is going to be changed. You can see what it will change. So it will also update your tests. You get the step-by-step, and then there's a smart action button telling you, hey, you can please write me code for that. And this will take a little bit longer than what you've seen just now, but then it generated code for you, and you can simply review it. And same as what you would do with an internal colleague, right? You can provide feedback. And if you're not happy with something for whatever reason, ask for an iteration. Ask for an alteration to change something what you don't like. And there you see that product functionality is added. And at the bottom, we even have test cases. Okay, so that's quite cool. The next step in the development process is monitoring and testing. This can be frustrating at points when you get error messages which you don't understand. This is a very easy setup in the cloud using a Lambda function. And you may run into an issue when you first build something and test it. Ask your development companion to help fixing it. First step is, again, understanding. So lengthy error message, what does it actually tell me? And it tells you, hey, you lack permissions. You need to have a different permission set to be actually able to put something in the DynamoDB table. And the development companion then is generating a resolution for you, right? So it helps you understand, but it also helps you to fix the stuff. And that takes a second, and there you go. Those are the recommended steps, right? Step by step, but maybe you don't want step by step. Maybe you even want an immediate solution available. And then you can ask your development companion, hey, give me an immediate solution. This takes a few seconds again, but this also reduces feedback loops and reduces the cognitive load and will help you to stay in the flow. You can copy it, and there you have your solution. And at the bottom, there's always the opportunity to provide feedback. Right? We always tell, work backwards from your customers, work backwards from your users, and like providing feedback will help to continuously improve your development companion. The last step in the software development lifecycle then is maintaining. We've learned a lot of people spend a lot of time there, right? And not everything about maintaining is a lot of fun. Thinking about, you have COBOL code, you have old Java code. Very hard to upgrade it to more modern languages. Think about COBOL to a modern language, or think about Java 7 to Java 20 plus. And the development companion should actually be able to help you here. The first step a development companion does is basically copy the code in a managed and secure environment. And then it starts to create a transformation plan based on some static rules, powered by some LLMs to fix everything which is not covered by static rules. And then it starts actually building and iterating over it. And you can follow that process in the transformation hub. And the last step basically is transformation is completed, and you can review the code and see that it actually builds. And this will help you in the maintenance part of the code. So to overall sum up, the first thing we've heard is developer experience is likely the best metric for developer productivity. We heard that platforms and tools can really help to increase developer experience, but only if you truly work backwards from your customer. So think about shortening feedback loops, increasing cognitive load and flow time. Make sure you interface with your users and customers. If you don't have a mechanism in place for doing so frequently, get a mechanism in place to actually have an institution on doing that. When thinking about working backwards, think about 52 minutes of coding per developer per day. Think about 73% running and maintaining, and only the rest is spent on innovation. So this is why we say coding companions are great, but what you need is a development companion. You need a development companion who really helps you along the software development lifecycle, from understanding, developing, testing, upgrading. You actually want, like Star Trek Q, you want an all-knowing mentor who you can simply ask questions to get answers instead of diving deep in every problem yourself. And we've heard from Robert that platforms do provide abstractions, and that can be great, but those abstractions can be illusions, and if they break, they leave your developers helpless. So our call out basically is spend less time building the perfect abstraction. Instead, have a development companion actually explaining stuff to you. And that's it. Thank you a lot for listening in.
Christian, Robert, hello again. Thank you so much for the talk and for the demos. It was very insightful. Since we have only 5 minutes left, I would say we jump right into a Q&A. First, you got a question to the audience. Do you work in a large enterprise, and does your company use coding companions at scale? Just write your answer in the chat and we will forward it afterwards. So, and we will make use of the last 5 minutes and jump to the first question. It was too big for a banner, so I will just read it to you. While agreeing with all the points, there's still the practical issue of who owns shared systems, like CI/CD infra, observability, test tooling, or shared KAs, clusters. Some third-party tools still require this. Separate teams or dev teams?
Yeah, for sure. I mean, first things first, yes, you will always have some basic IT services like networking and so on that somebody has to share. There are services that you need to run in platform teams simply because they are built in a way that is centralized. So you need a centralized team to run them. That's for sure. The option you have, especially with cloud, though, is that a lot of services you can actually run as separate instances for individual developer teams, and that can make it much easier to run in a more decentralized way. One more thing about sharing or sharing responsibility is I am of the opinion that as you progress, at some point the developers will know more about the services they build on than the platform teams. We already see that, for example, with serverless, right? With serverless, the platform team doesn't have to do much, but actually developers know all the small problems and things you need to know to really employ serverless in a good way. So this is where we really advocate for like a shared responsibility system, meaning you are collaborating on things like templates and best practices.
And this can only work well if you really interface with the users frequently, right? And not via email. Have a mechanism in place.
Right. Thanks for the answer and the tips to both of you. Our next question is a more general one. As companies grow, what should they do to keep developers working efficiently?
My short answer would be try to apply the DevOps framework. Do you want to add something, Christian?
No, that's a great question, and there are tons of dimensions to it. But yes, the DevOps framework is a really great tool to look at all dimensions, right? From satisfaction, collaboration, efficiency. It covers it all, and it forces you to frequently interact with your developers and to figure out what you actually need to do to keep developers working efficiently. Talk to them. They will tell you.
All right, thank you for this as well. Next question. How do remote or hybrid work environments impact developer productivity and what can be done to improve it in these setups?
Oh, that's a good one. Actually, I think I'm not really the expert on that part. So I think Christian and me were focusing a lot on productivity in the sense of a lot of the work the developer has to do as an individual person. We're thinking about collaboration, as we said before, specifically in collaborating on templates and best practices. I have to say, really, for hybrid work environments, I think I'm not the best person to answer that.
I have to agree. It's a great question. The answer.
All right. Then we have time for maybe one last quick question. Maybe this one. What are some ways to measure if developers are working productively?
Yeah, I think I think that's what I tried to show you with the 3 layers of the DevOps framework. So you can ask developers, and they might tell you, yeah, everything's fine. I release once a year, great. And then you basically base that with the workflow metrics that you also try to collect to see, like, okay, this developer thinks it's fine, but actually the metrics could be better. So that's how you're trying to look at both of those things together, and then you're discussing with the developers, do you really feel productive or could this be improved?
Mm-hmm.
Telemetry data plus surveys and frequent discussions. This is the best way to also know where to look for further improvements.
All right. Then thank you for the answers and thank you also for the amazing talk. It was a pleasure having you. Sadly, we ran out of time, so to the audience, if you still got some questions to them, reach out via their socials. I think Robert is is nodding already. They will gladly answer those as well. So yeah, Christian, Robert, thank you so much for joining us today, and hopefully we see each other again on another live day.
Thank you a lot for
Thanks
listening
a lot for
in.
having us.
Thanks, guys. Bye-bye. All right, and we move on to the second speaker of the day. He's trusted advisor at Tallence. With his many years of experience, both as a developer and system architect, he can advise customers and also his colleagues on cloud infrastructures and cloud native technologies, and he will also share some of his knowledge today with us. Very welcome, Christian.
Yeah, good morning, Bene. Thanks for having me.
Yeah, thanks for joining us, Christian. Awesome to have you. So, before we start with your talk, would you mind sharing with the audience and me a bit about what we are going to learn from you today?
Sure thing. So, from the title, I think several topics might already be graspable. I'm going to talk about platform engineering, about developer productivity, about DevOps, changing roles, and how to accommodate with that, how DevOps and platform engineering can help here, and why they have to be always thought in combination and are not, well, something that is in contrast to each other.
All right, that sounds very interesting, Christian. So I would say the stage is all yours.
Okay, so thank you very much. I mean, I'm already introduced, but then again, hi everyone, my name is Christian, and as you can see in the background, I like to play guitar and I like to drink espresso, and professionally, I'm trusted advisor for a company called Tallence. The title is a bit odd, and to be honest, I haven't really heard it outside of our organization yet. To give you a better understanding of what I actually do, think of me as kind of a staff engineer that advises colleagues and customers on all aspects of cloud infrastructure, cloud native technology, and software development. You can find me on LinkedIn and other socials and by my name, and I'm on the Fediverse, where I'm mostly boosting toots and not doing things on my own, as abith@hatchydam.io. Tallence is a software consultancy based in Hamburg. I'm working remotely from my home, and I'm speaking to you from Mittelhessen. In the Value Stream Cloud, we usually help our customers on all parts of their way to the cloud. And among others, this also includes cloud native development, distributed architectures, and, you might have guessed it, platform engineering. We are hiring, so if you jump over to tallence.com/jobs, you can find job listings, and unsolicited applications are welcome as well. Just tell them I sent you and we can work things out. So today I'm going to share my experiences with platform engineering, DevOps transformation, and, well, software development. Why platform engineering can help organizations in their DevOps evolution, but is no mere replacement of it. I mean, you might have heard it last year. There were some big marketing stunts claiming DevOps is dead and platform engineering is here to save us all. And I have to say, no, at least not yet. And we're probably going to discuss more about this later. But first, why did I choose to talk about this topic? To me, the real value of software is only delivered in a production setup with customer interaction. Everything interesting usually happens in production. Also, things nobody understands usually only happen in production. So I have a systems background. Back in the university days, I was tinkering with Unix systems. That was kind of a hobby. I mean, having a portable computer that just works is boring, right? And afterwards, I fortunately or unfortunately, depending on who you ask, had less time to continue with this. So I had to pick a system that just works and not fiddle and toy around with it anymore. I've had my fair share of roles over the years. I was a software developer focused on distributed systems, a performance engineer for HPC environments once, co-founder for a startup, have been a project manager, developer consultant. So a lot of different perspectives. And I think most likely due to my systems background and, well, these changing roles, I was often responsible for topics where interacting with other departments is necessary and, well, for nitty-gritty systems things. And experience with setup and maintenance of infrastructure usually leads to projects that are heavy on infrastructure. And if you just start out with platforms where software is going to run, it's just a small step to also managing the build systems that are required in a project, so pipelines, container clusters, cloud environments in general, and so on. So I've been building platforms for digital projects for many years and products, and technology-wise, a lot of things have changed. But the more crucial aspect here is the perspective of the business side is also different now. With this, nowadays, nearly everything is a distributed system. People need skills and knowledge from more and more domains, and, well, systems are becoming more and more complex. I don't think this is surprising for anyone, but if I think about it, I'm not sure since when this is actually true. But if I take a look back, for as long as I can remember, things are getting or becoming more and more complex. Back in the days, people were writing software, were also in charge of running and maintaining it. It was just natural, right? Building software, deploying things via FTP or something, and then taking care that things continue to run. Over time, development and operations got more complicated, I have to say. And as business needs to focus, people had to specialize, and so dedicated roles for developers and operators were created. This does not stop with developers and operators. Nowadays, there are also QA departments, security departments, and so on. But you get it. And I can fully understand why this happened, but I still think this was a mistake. In hindsight, it is easy to say, right? But the results were different departments at times really hate each other. And I've seen companies as a consultant where developers really frown upon operators. Things take so much time, they make things complicated, they don't understand us, don't understand developer needs, and said operators were responsible for, well, basically everything besides the developer IDE, and had the impression that they can't get things right, that developers don't know what they're doing, and that they only always create work and request things. And the really sad thing with this is that there's a kernel of truth to both sides. Depending on how long things are going this way, it is really hard to resolve this. I mean, yeah, usually the recommendation of just talk is not wrong, but also not really helpful, right? So that's what DevOps was invented for 17 years ago, right? So nothing revolutionary, nothing new, and yes, it was. But before we can discuss this, I think we have to define what DevOps actually is, or what I am going to assume in this talk. Because while I really like the concept and the implications of it, I don't really like the name. It really is not a good name, because I'm not sure if it's just because of the name, but one has to always discuss what it actually means. And in this case, at times, I wonder if it was picked deliberately to make things harder. But, well, I digress. To quote Ken Mugridge of ThoughtWorks, DevOps, a culture where people, regardless of title or background, work together to imagine, develop, deploy, and operate a system. And I really, really like this definition, because just from this definition, you can take a lot of the meaning of it. First, there's culture. This means you can't simply do DevOps. It's not a role. It's not something that you can dictate upon people. It's not something you simply follow by rote or can be ordered. It is a mindset and a way of working, and, well, requires changes. Then, regardless of title or background, not only developers and operators are considered in this. I mean, I'm not sure if you've heard about it, but let me just coin the term DevSec test fin data ops. You could probably add more nouns to it. This just means everybody with stakes in a product is involved here. Developers, operators, security, but also the business side of things. And all of these people have to work together to imagine, develop, deploy, and operate. So they have to join forces to reach a common goal. And this goal, or having such a goal, is really important, because this points out where everything is directing to. And in the end, operate a system. And why is this crucial? Because there's no value if it's not in production. I mean, right? If there's no customer interaction, nothing's really going to happen. And if you take this seriously, DevOps is about more than just Dev and Ops. But whenever I use the term, I think of all these parties involved. And this is the main reason why I don't think that DevOps could be considered dead, or anytime soon will be dead. But depending on the way you see it, and the name is a bit problematic in this, you could argue that it only really applies if there are developers and operators. And the landscape is changing, roles are changing, and what their meaning are also changing with it. So if there are no developers and no operators, do we really need DevOps? And we'll see. But first, let's focus on developers in this regard. Developers are usually asked to, well, just shift left, right? The shift left model here focuses on software abilities. This means that early on in the development process, you are asked to already consider things that usually were only considered later in the line. So something like security, scalability, reliability. And if you think about it, this really makes sense, right? Because if you do not think about scalability early, you're going to have a bad time later on. And in theory, this sounds really convincing. And I can't resist to put a quote in here. Not sure if you've heard it, but in theory, there is no difference between theory and practice. In practice, there is, by Yogi Berra. But in this case, in practice, this still is true. But you can't just simply shift the responsibility and expect things to go well, right? Developers should be the owners of their software, but because systems can only really be operated by the people who write them. If you're not the author, you will always miss parts of the picture and won't be able to fully understand things happening in production. I mean, at times even the authors don't understand things happening in production. And if you're also not the author, you don't have any influence on how much insight an application is giving you in production. From an operations point of view, it might be sufficient to have system-level metrics and have logs. But developers might also require tracing to actually get more insights in what the application is doing or what user flow is doing. So this is really something that you only can do if you're also the author of the code. And on top of this, operating a service provides a crucial feedback loop, which you really need for development as well. I mean, if you are not going to be paged in the night when something that you've built is failing, well, maybe you don't really grasp what you're doing. But simply asking people to do this is not enough. They need support for this. I mean, we've all heard of the 10 times developer, and I think Kelsey Hightower once phrased it like, there is no such thing as a 10 times developer, but the person who is making 10 other people more productive is kind of a 10 times developer. But I really like another quote by Charity Mages. Show me the web dev that writes their own device drivers. And I think this highlights it quite well. Usually people can't concentrate on everything. Think of it like a role-playing system. You can't put an 18 on everything without cheating, or in the case of Dungeons & Dragons, ungodly log with the dice. But that doesn't mean that you have to become a glass cannon or anything. Learning new things is always worth it. You just have to carefully pick what you're going to learn or what you want to concentrate on. For example, from my point of view, at times, I would really like it if more people would be familiar with TLS, because I have to explain this quite often. But if I am about to join a developer team and write code with frameworks that I'm not familiar with, they tend to show me things that are new to me, but are already established industry practice. So be empathic here. And the same is true for operations. Other people, and I mean this as in other as traditional operations, are taking ownership of software. Well, that leaves operators with what? Operators nowadays work with abstractions via infrastructure as code and provide additional high-level services and support. Unfortunately, they have to do this usually with less people than they used to, but this requires different skills than just managing a server in a colocation or data center. So you're providing something new, you're providing more of it, and your operational expertise that you have is more crucial than ever, because it's not sufficient that you know how to run things, but not necessarily the knowledge, but the capability of running things is something that everyone requires now. So what you need to have here is a culture in which all involved parties work together. They have a common goal, right? One side wants to develop things, and the other side wants these things to be running productively. And this is where platform engineering comes in. Again, this is also a bit of a problematic term. Let's define what this actually means, as there are different definitions out there. What is platform engineering? Platform engineering is the discipline of designing and building self-service capabilities to minimize cognitive load for developers and to enable fast flow software delivery. There are multiple definitions out there. This one's from the State of DevOps report of 2023 by Puppet Labs. So from a technological point of view, luckily, cloud-native technology drove huge improvements in this. For scalability, availability, and operability, they're easy solutions. Orchestration of different technologies allows a high degree of automation and abstraction. But as you can see from this quote here, platform engineering is more than just technology. Platform engineering is a socio-technical discipline. I have to say, the technology here is the easier part, but let's start with this. The technical part is what is often coined as internal developer platforms, or IDPs. Such platforms feature self-service offerings, enforcement of policies and standards, established best practices, and simplified abstractions. Typically, these self-service offerings are application configuration management, progressive delivery, certificate domain management, so things that developers might require and in the past, for example, required a ticket, should be designed in a fashion that people can request them in an automatic fashion on their own. One highly regarded feature that is an orchestration of multiple of these things would be one-click deployments, for example. And as usually when I talk about this, people don't really grasp or give me feedback that they don't fully understand what I mean with such an internal developer platform. I've prepared kind of a short graphic for this. This is a technical overview of a platform that we've built for a customer. I don't want to jump into too much detail here, but I think this gives a good impression on things that usually are offered this way. You can see here we've combined services on Microsoft Azure with services being hosted by a central IT operations department. These are listed here in gray. And on top of this, there are also services in this graphic with a UI, or a capability that was abstracted for users. This includes service exposure, application delivery, UI of running services, and as you can see down below, a central user identity that is managed with everything around this. So you see, there are a lot of tech icons here, there are a lot of capabilities back in here, and what is really crucial is that you have to think of the developer here first. You have to offer something easy for them to use with it. So don't think in tech stack, think in high-level features here. But as I've said, platform engineering is a socio-technical discipline, and the social part involves just that. It's about user-centric design, taking the customer first, professional and team support services for teams to enable them to develop and run their products. This is very important, as it really is all about the developer experience. We've heard it in the talk by Robert and Christian before. This is the main focus point here. We want to enable people, we want to increase the developer experience and their productivity. And because of this, support has a really wide range here. It covers traditional tech support, but also includes things like reference implementations, dedicated enablement teams, a clearly specified roadmap based on these user needs, feedback, and documentation. And depending on the level of the platform we're speaking about, documentation also ranges. This could be just a wiki page, a guide, a playbook, but it could also be a bespoke CLI tool that has kind of a wizard functionality for onboarding or creating a project or some kind of tutorial. And other support options might also include defining office hours or joining app development teams as a temporary project member. So the sky's the limit here, but the central goal is increase developer experience. And if you join such a team, this also provides unique insights into the daily problems of them. So you have to really ask them, but they might not fully answer you. So seeing things, seeing how they're operating with things gives really, really crucial insights. I encourage you to experiment with this and find what is working for you and your users here. And all of these parts are neither new nor revolutionary. This combination of people and tech, that can make a difference. You see, platform engineering is popular both as a buzzword and as a concept. I've quoted the State of DevOps report 2023 for my definition here of platform engineering. Well, these are the cover artworks of the issues for 2023 and 2024. You can see here State of DevOps report, Platform Engineering Edition 2023, and State of DevOps report, the evolution of platform engineering 2024. It was decided that they not want to go on with the name State of DevOps report, but focus on platform engineering instead. This is due to the fact that some organizations have internalized the concept so much that they stopped using the term, and people who are frequently using the term don't have a different understanding of what it actually means. And on top of this, there's a huge opportunity that platform engineering offers, especially for large companies, to improve software development and delivery. And this is a trend for quite some time now. This graphic here is from the 2020 State of DevOps report and shows that usage of internal developer platforms correlates with a high level of DevOps evolution here. And Gartner agrees. Gartner speculates that by 2026, 80% of large software engineering organizations will establish platform engineering teams as internal providers of reusable services, components, and tools for application delivery. Okay, so just 2 more years then. This sounds lovely, but why are organizations still struggling then? I mean, DevOps is 17 years old. Depending on who you ask, golden paths specified by Netflix are more than 15 years old. Why are organizations still struggling here? If we were in a room together, I would really love to get feedback from you. So I would really love to hear some opinions from you before I continue with this. So just feel free to reach out to me or put things in the chat. I'm really curious to see what you think. But to go on here, in my experience, this is not something to be there's no simple answer, but there's something you can do. In my experience, and the community seems to agree, you have to treat the platform as a product and use product thinking. Okay, but what does this mean? First, let's focus on what a product is. Team Topologies, a book that I'm going to highlight here, has the definition: a platform is a curated experience for engineers, the customers of the platform. So you see here Team Topologies by Matt Skelton and Manuel Pace. I highly recommend reading the book. But from this, we can take that the design of the platform should be based on user needs and requirements with a strong focus on the experience here. So you actually have to talk to your users continuously to learn about their problems, what you have to solve, and deliver something that makes their life easier. You really have to focus on the outcome and have an open roadmap based on their requirements and feedback, and offer support. But as usual with things like this, it is very, very crucial as well to start with something small. So iterate in small steps. Build something meaningful before you build simply anything. That prevents that you're building something that nobody wants, but something that really fits a purpose. There is a saying, build it and they will come. From my experience, this is just simply not true. If you just build something, or if you think you know it better than other people, they might use it, they might test it, but usually this is not a successful path to take. People familiar with agile software development know that product management and thinking require special skills and a mindset. And I could not resist to include this graphic to the slides because in my eyes, it illustrates the problems quite well that different interpretations of requirements by different departments have. This graphic here is from a source that I've listed here, but the original one, or the general idea behind it, is from the 70s. So this is also not something new. Communication is hard, and speaking in requirements is hard as well. So careful design and curation with the user in mind is mandatory. And to be able to do this, user research is key. It really helps to think in personas, as you're developing something for other people with a different background and requirements. And usually when I am asked to develop something where I'm not the target audience, I really have a hard time if I'm not trying to think what they like and are not going to like. So I would recommend to include designers into your platform team, or to speak with them on a regular basis, because they are really familiar with this problem, and understanding users and how to conduct surveys and things like this is really hard. But you can really learn when you speak with your users or watch how they're interacting with your product. Don't know if you've ever done this, but if you have a joint call with people where you're trying to debug something, it really helps to watch what people are doing, what assumptions they make, what kind of shortcuts they might want to take, or what angers them, what works well. You can really learn a lot here, something that people not necessarily are going to point out to you. Because if everything is working well, people tend to just take it for granted. If things are breaking, people are quick with saying that things are breaking. By getting more nuanced information is challenging. And yeah, so next, you have to focus on workflows and tooling and interoperability, because the sum is more than its parts. It's not really helpful if you have something built, you have to build infrastructure, but think of it more like composing architecture as a product. Depending on the purpose of your platform, the ultimate goal might be to offer reliable end-to-end workflows so that your developers can use the platform to achieve what they want to achieve. And this from the beginning to the end. As one could easily fill a talk just about product thinking, how to conduct this in general, and platform as a product in particular, I would like to recommend some additional resources about this. In general, I highly recommend the talk Platform as a Product from Manuel Pace from PlatformCon 2022, and the book Team Topologies, where I'm taking some definitions of, and which is also listed here, and where Manuel was a co-author. The book shows how a platform can be offered as a service to teams, what kind of team topologies there are, and how they should interact with the platform, or how you want to orchestrate your teams. And in addition to this, from Platform Engineering 2024, I would like to recommend the talk Boosting Developer Platform Teams with Product Thinking by Samantha Hoffmann. This talk is in particular interesting because she is a product designer and was, in this case, speaking about the technical domain of product engineering and how design thinking can help with this. Video recordings are publicly available for both conferences, and there's, of course, much more to discover. So feel encouraged to take a look. Now that we've established what platform engineering is, what problems it solves, and how to best approach it, I want to give you an additional guideline for the conception or how you can design an evolution of your platform. There is a platform engineering maturity model. In best consultant fashion, I would like to encourage you to use such a maturity model to determine where you're currently standing and what next possible steps are. The model is rather new. It was donated to the CNCF by Synteso, and it still is constantly evolving. I have to say, I've not yet used it with the client, but from taking a look at it, it is looking very promising to me and makes a lot of points that I usually also tend to make. As not everyone is familiar with maturity models in general, I would like to give a bit of an introduction first, though. This is not kind of a high score or one established path that you have to take. It's also not really necessary to reach the highest level of anything. Take it more as a guidance and a decision helper. It helps to highlight limitations and opportunities that you might have in your platform engineering. And to quote Martin Fowler, the true outcome of a maturity model assessment isn't what level you are at, but the list of things you need to work on to improve. Your current level is merely a piece of intermediate work in order to determine that list of skills to acquire next. So this is said maturity model. And before I'm going to talk about the content here, let me give a warning. Each additional level of maturity that you can see here is also accommodated with greater requirements for funding and people's time. So simply reaching the highest level should not be a goal in itself. Okay, with that out of the way, let's talk about the different aspects here. On the left side, you can see different aspects. There are short strings, short text snippets explaining what is meant with them. And on this side here, you can see different maturity models. So you have investment, how are staff and funds allocated to platform capabilities, adoption, why and how do users discover and use internal platforms, interfaces, how users interact with it, operations, how platforms and capabilities are planned, how they're operated, and an important part, measurement. What is the process for gathering and incorporating feedback and learning? This includes user feedback, or mainly includes user feedback. And on a maturity level, you can see here, there is provisional, operational, scalable, and optimizing. And usually depending on the aspect, you might have a very different maturity level. And in general, I would recommend to take these points on their own, but as this is socio-technical and involves a lot of parties, usually this tends to not be possible. So you might find out that one aspect might influence the other, or that you require a specific level of some things. So I would recommend to take a look at this, take a look at the maturity model in general, then find out where you're standing. But before you take action, you have to make sure that you, know what you want to achieve. Keep in mind that each aspect is meant to be evolved independently, but be aware that you have constraints with which you're working. You have to improve iteratively and try things out. As I've already said, start small, make small steps, experiment, and make sure that you're building the right thing, not just anything. And the crucial aspect here, it's a socio-technical thing. you can't just consider technology here. You have to consider people, you have to consider processes, you have to consider policies. There are a lot of influences here, and all of this should influence your decision making. So hopefully you now have something that can serve as guardrails or give you an outlook on how to concentrate on things next. What I want to share with you are stories where platforms are failing. I mean, failure stories are always funny, right? But in this case, they're not necessarily funny, but I want to provide you with insights of common issues and how you could probably work around them or not run into the trap, so to speak. So, why are platforms failing? First point that I want to make is platforms are a cost center. And I just have to say it, platforms are a cost center. In the end, infrastructure is exactly that, a cost center. It might enable business cases, create competitive advantages, enable developers, but still a cost center. And because of this, you want to limit the amount of infrastructure that you're having. A good platform is just big enough, but not bigger. Analog to the minimum viable product from agile software development, there is the thinnest viable platform. This is also a term coined by Manuel and Matt in team topologies, but this requires continuous effort because writing less code is harder than it sounds. And in addition to this, it is essential that the business of the company also cares about the platform. Its value has to be visible, and well, leadership usually requires measurable. You have to communicate it regularly, and depending on the maturity of the platform and the products, this is something that's not there yet. We've already heard about specific metrics or frameworks that we could use for this. DORA was mentioned, DevOps was mentioned. Other things that might apply, I mean, already included here are cost savings or simply how happy the people are. This can be really hard, depending on how technical the leadership is, because you have to communicate things in a way that are understandable for all parties. But if this is not done properly, the business side might deprioritize needed topics, cut costs in general, or otherwise hinder the development and the evolution of the platform. For example, something that I'm familiar with because I've seen it several times is that leadership tends to give additional tasks or responsibilities to platform engineers. And this can really, really hinder things because simply keeping things alive and well is a task on its own. And you have to accommodate a lot of time for support and open topics and research and development. But I have something for you, how you can simply test to see whether a platform team is really a platform team. This is also something that Charity Majors once coined. Is the team responsible for SLOs, service uptime, and reliable customer experience? If it is not, then congratulations, you have yourself a platform team. If it is, well, not really, because you have people who are doing platforms and are doing infrastructure, but they're doing something else. Because the responsibility for SLO, service uptime, and reliable customer experience should be at the developers and SRE's hands, so the app teams. And platform engineers, or the platform engineering team here, should be responsible for developer productivity. So, platforms are a cost center, but they also provide value. Make sure that this value is clear so you can get proper funding and can plan ahead. Next, users are not taken seriously. There are different manifestations for this problem. First, assumptions about what people think or want or are able to do are being made. In a way, it is either assumed that people will use the platform regardless of the value it proposes, or that value is highly misjudged. This might not happen out of malice. You have to keep an open mind and take the time to fully engage with the end users. I mean, CLIs are somehow not for everyone. I've spent quite some time in my professional life going through YAML files with people and had, well, different experiences with different people on how they could interact with it. Second, there is organizational pressure to use the platform, either for compliance reasons or just to make sure that the resources used for building it are well spent. There might be good reasons for this. Usually, we want people to use the platform. We want to establish standards. We want to enforce policies. But if we don't give users a choice, we can't have open discussions and proper feedback after. In my experience, if the developers aren't involved in the platform, it is not going to become a success. I've seen platforms built by operations teams or other people, or leadership-induced paid platforms as a service, and somehow they both failed. And this is something that really baffles me, because if you compare this to other industries, the IT world is a bit on its own here. Solomon Hykes had a keynote at this year's KubeCon and compared this to real-life factories. If you design a product, you also design a factory for it, right? Of course, every factory is unique and every organization is unique, and there is no one-size-fits-all. But when you want to build a product, you have to accept that you somehow have to build it. And so you have to accept that you have a factory, but own it. See improvements of the product and the factory as an integrated process. What I want to say with this is, it really is fine to build something on your own if you are aware that you're doing it. There are paid solutions, but usually you already have something. And finding something that works for all parties involved, doing it the user-centric ways, is hard and usually involves doing something on your own. So take users seriously and truly make usage of the platform a choice. Next. The platform is a jack of all trades, but really a master of none. In the life cycle of such a platform, there are times with lots of feature requests and times completely without them. If you're only fulfilling external requests without a strategy or a communicated roadmap or a goal, this usually leads to feature creep and bad user experience. It is vital to focus and to continuously try to improve quality. So I would recommend to really focus on quality and only build what you need to build. To be able to do this, the platform itself needs a purpose and its strategy. Depending on said purpose, it also might be necessary to accept that there will be use cases that you can't or don't want to fulfill. Think of a mainframe application that all of a sudden needs to run on Kubernetes, which no sane person would ever do, right? Or running a container cluster on a mainframe. Who besides IBM would do that? I don't know. Well, at other times, someone might request a different flavor of an already offered service. Think of a different database, different workflow engine. And I get that there is a need to standardize things, but we can be pragmatic here, right? Do I care if developers run a MySQL database or Postgres database? Not really, as long as I'm able to manage both or offer the high-level service for both. Maybe someone is using a service but is having problems because certain crucial aspects can't be configured. And getting abstractions right is really hard. Think of Helm charts, YAML templating, or think of managed services where you're only exposing certain knobs and switches to people and all of a sudden somebody wants to do something entirely different. Value this feedback because this is the best you can get. This means someone is already using what you're offering and wants to improve it, or it needs to improve to fit a purpose here. There might also be situations where this is not possible, and then it might be necessary to build a solution for this next to the platform, but in general, this is the best feedback you can get. Try to accommodate it. Speaking of things that might not be a core use case of your platform, at times it might also be necessary to deprecate things, right? Features bind time. If you're managing a platform, simply keeping things running and up to date takes time. Because of this, I encourage you to monitor the usage of your services and openly discuss plans and roadmaps with them. You need to have a strategy and a clearly communicated roadmap for your platform. accept that there are things you can't do and that there are other solutions too. Having opinions and clearly communicating the how and why usually helps with these aspects. Focus on building the right thing, not just anything. And finally, platform team is not fully cross-functional. And this is a big thing with a lot of different aspects. Let me try to get through things. Usually organizations pick a lot of operators or people familiar with IT operations to build such a platform. People like me, right? While this might not necessarily be wrong, I mean, they know how to operate things, right? There is a risk that the solution will cater for their expectations and assumptions. So platform teams should include application developers, or at least people with an application mindset who are used to development processes and are used to, well, developer challenges to make sure that the abstractions and offerings work, right? On top of this, the size of the team should not be too big. It might be tempting to add or switch other people to the team for knowledge transfer reasons, but keeping a small and stable team will be beneficial in the medium and the long run. I also encourage you to build processes and use tools that allow your team to stay this way, even with increased platform usage. Another aspect is that is often neglected or completely missing are product management and product thinking skills. Product owners really are important to provide the correct mindset, guide the team, and evangelize the platform. If there is a product owner, there should also be a mandate to act like one. Very often in my career, product owners were either not capable or simply not allowed to make decisions that they were required to do. The product owner of a platform should also have a solid technical understanding of it. This way, discussions about prioritization, user feedback, and requirements are really possible, and the value of the platform can properly be reported to the leadership. And product owner must also be allowed to do all of this. It is vital that the product owner has the trust of the organization to really own it. Otherwise, the sole purpose of him will be that of a messenger and of decisions being made by other people. And this leads to uninformed decisions, a lot of wasted time, and will neglect real user feedback. You've most likely already grasped it, but between the lines you could also see it. I recommend to use Scrum or a different agile framework for product management for internal developer platforms. We've had a lot of success with it, but this puts a hard toil on the product owner and all parties involved. But Scrum goals and values align quite nicely with platform as a product development. So you need a true cross-functional team that is capable and allowed to develop a platform as a product. Finally, you've heard about common issues and hopefully now know how to avoid them. We've talked about the problems platform engineering is trying to solve, but let me summarize a bit. What do I get for all of this, right? This is sounds like a lot of work, but there truly are some benefits. There is improved developer experience and productivity. This is the main focus point. Usually you have happier users with a reduced cognitive load. You don't have silos anymore, or at least drastically reduce them, as all departments are collaborating with each other. I mean, even the business guys, because they can see how much money they are saving, right? With such standards, you also have properly aligned tools, services, and everyone is following the right policies. You don't bloat anymore because you're deprecating things that are not needed anymore, and it's easier to manage technical debt. In the end, you get a platform that is reliable, usable, and fit for the purpose. And best of all, it's designed to evolve so that it can stay this way. So to summarize what we've learned today, engineering rules are changing. Platform engineering can help organizations on the DevOps evolution. Setting a goal and being aware of constraints is vital in your platform engineering journey. And you have to treat the platform as a product and use product thinking. And with this, coming to an end.
Thank you very much, Christian, and hello again. So yeah, thanks for the talk and fitting last slide, because yeah, we got some questions for you. And if you're ready, we could tackle them right ahead. The first one. Developer platforms are very popular now. Are we at their peak, or will they continue to evolve? what do you think might be the next big thing after the current trend in developer platforms?
That's a very good question. And usually talking about the future is hard. But my opinion here is that things are going to evolve because from a technical point of view, everything is changing and will be changing constantly. The more dramatic thing behind the scenes here is that with platform engineering, we kind of separated infrastructure from software operations, right? Because we are probably buying infrastructure from AWS or others, and dedicated people are orchestrating things running on these. And the operations part is now separated all over the organization. And I expect that this will be true for other things as well. This is not only about development and operations. This also includes, for example, finances with FinOps and Co. So I expect that more business requirements will find their way to teams in this fashion and that things are developing or evolving this way. So I think platform engineering is here to stay, but the aspects or its more core points are going to change.
Yeah, outlooks in the future are not often that easy, but yeah, thanks. Thanks for giving us yours. And I give you the next question. How does platform engineering support scalability and flexibility in large scale or rapidly growing projects?
Good question. Basically, by speaking with the users and making sure that their requirements are heard and properly addressed. To build something that supports scalability and flexibility is, well, not necessarily easy to do, but if you are aware of these factors, you can do so in the beginning. So I would say platform engineering is exactly the right tooling for this, because in the beginning you can plan ahead, build something, or build more than one thing. For example, it could be fully fair to build several platforms or have multiple Kubernetes clusters depending on product teams.
And as so often, communication is key.
Yeah, and flexibility is the big point here. So concentrate on the things that you have to solve and resist the urge to gold plate things.
Great, thank you, Christian. Next question. How can platform engineering help developers and operations folks work better together?
That's a really good question. I would like to point to the team topologies book here. There's also a page that lists several DevOps anti-patterns, which I think also apply here. It's crucial that you set this up the right way. If you have a platform team that consists of all involved parties, or at least enough that you can really solve the issue, you have some additional party here. You have development, you have operations, you have platform teams, and if you think this through, it might be that operations or part of operations might be a part of platform teams. It might be that developers might be a part of this. So if you develop a platform, you're defining interfaces. And these interfaces are not only for developers, but for operations as well. Because if you're building such a platform, you're orchestrating services that either a cloud provider or your central IT operations team is building for you. So this is kind of an interface in between, or something that unifies them. You can think of it like both departments have to share the same goal, and platform engineering makes this tool graspable, so to speak.
All right. Thank you, Christian, for this as well. We got another question. How does platform engineering make life easier for developers?
Well, first of all, because it offers self-service offerings. I don't know if you're familiar with this, but in the past, if people required to run their software at some place, they usually raised a ticket. They had to describe things. There was kind of a back and forth. You had to wait for things. You would not be able to get access. You might need to use a third-party system developed by another person to get things running. And in the end, somebody would do something with the application that you're not even aware of. Then there would be errors. You would have a lot of issues. And most of the time, this is the case if things are not properly aligned well. So this makes life easier for developers in the way that they can concentrate on what they need to concentrate on. They build abstractions for things that they have to fulfill, for example, security policies, something like registering domains, management of certificates, that everything's up to date. And this makes it easier to concentrate on the development process itself, because what you need to develop, build, and run your software is something that is abstracted for you. So somebody else is thinking how to solve these problems for you and with you.
Thanks for this answer as well. And we jump right to the next question. What should developers learn if they're shifting to a platform engineering approach?
This depends a bit on whether or not developers aim to join a platform team or if they want to work in an organization where such a platform is built. If the first part is true, then I would really recommend product thinking, because this is something that people lack the most. And learning things from other people in such a team, usually the technical things usually happens fast and quick, and things like product thinking is something that might take a bit longer. If it's how developers should approach platform engineering in their organization, if they're not a part of it, I would really encourage people to give feedback and to talk to people. Tell people what you need, what your problems are, but tell people also if you're happy and things are working your way. And if you're used to providing feedback, if you're used to interacting with others, and also share planning sessions where future features are discussed and roadmaps are discussed and decided, everybody is going to benefit from it.
That's awesome if everybody benefits from it. Perfect. So, and we for sure will benefit from your next answer to this question. What are some best practices you found for implementing platform engineering effectively?
Okay, the biggest thing I have to say is in the title, you have to take it as a product. You really have to ask users what they need. You have to build things for people, because if you don't, you build something that nobody's going to need, or you build something that makes assumptions that are not solving problems for anybody. So developers as a product have short cycles, start with a small team, start with something very small and iterate and experiment a lot. I mean, usually people don't know what they want unless you show them what they can have. And this is true here as well. So experiment, build different things, start with a small team, and treat it as a product, truly as a product.
Right, thank you. Next question. How do you keep the roles clear between platform engineering and DevOps teams to avoid confusion?
Well, a DevOps team in itself might be kind of an anti-pattern here, but I think I get the notion of the question. Usually it helps if all involved parties discuss what their roles are and what they bring to the table to make sure that, well, everything is aligned and well in here. If you have a platform team in your organization, it really helps to make sure that everybody's aligned on what this platform is offering and what other teams in the organization are doing. Team Topologies is really the book that I can only recommend here, because this shows you how teams can be aligned to a common goal, to streams, and to interact with each other, how services are offered, how they are used. And this really helps with exactly this.
Okay. Some more content to dive into this topic. Yeah, thanks for the recommendation, Christian. Always nice to get more info from different sources. So, and we got another question for you. What are some of the biggest challenges you've faced when building platform engineering setups?
Usually a big problem is that depending on your mandate and depending on the trust that people put in you, you are going to have to work tremendously to make sure that people understand what you're trying to achieve and that you're there to help people. And if you've built that trust and if you have something that is working and people are using your platform, what really is challenging is not only keeping things running, but then develop things further. I mean, I have a systems background. I'm used to firefighting. And when you're done with the firefighting, when things are running and nobody's clearly screaming to you, I need this, I need that. You have to sit back and think, what is something that people might need, or where can we improve things? And this is hard, or at least it is hard for me, as I've neglected this in the past.
All right, yeah. Learn from Christian's mistakes and right. So, Christian, before we close the session, I would be interested a bit in your, how would we call it, developer journey. Would you mind sharing a bit with us how you became interested in tech at first, and what were the steps that brought you where you are now?
Sure. I think I have to give a pretty boring answer here. I was fascinated with computers from my childhood on. I think one of my best friends had an uncle who was really keen on technology and had computers very first, and my aunt was very keen on video games with Game Boys and stuff like that. So I had a tech fascination relatively early in my childhood, and from that point on, I decided that this is something that I want to concentrate on. So I knew back in my school days that I would want to study computer science. And this is in a way fascinating, because previously I thought something like archaeology or paleontology would be something interesting, or becoming an astronaut, But yeah, I focused on computer science relatively early, and then just kept my interest with it. This was something that I had as a hobby besides school. So I was tinkering with technology, learning to program things. And when I started studying computer science, I had a bit of a head start because of this. And things stayed interesting for me. And from that on, it was just, doors were in a way opening, so to speak. So parts of my career were not necessarily planned or decided by me, but things were happening and I reacted accordingly.
Awesome. Yeah, as so often. And I love your other profession choices. I mean, they're awesome, but I'm glad that you took this one, because this way we had this awesome talk today by you. For which I want you to thank you for making time for us and preparing this talk for us. It was a blast having you. And thanks also for all the valuable information you also shared during the Q&A. And Christian, I hope we see each other again on another live day.
Pleasure is all mine. Hope to see you.
Bye, Christian. All right, and we jump right to the next speaker of the day. He's lead developer at Spark Fabric. He loves to create and share content that educates and also inspires other developers, and he also speaks occasionally at conferences such as ours today. Very welcome, Eduardo.
Hello. Thanks for having me. Actually, I kind of transitioned from a lead developer role to DevRel this year, so I will be more active at conferences.
Perfect. Happy to hear that. Yeah, I mean, we know each other from another life day already, so this role fits you perfectly, I would say.
Thank you.
And yeah, before we dive deeper into your new DevRel role, would you mind sharing with us what your talk is all about today?
Sure. I will talk about WebAssembly, which is not something like I use every day. I'm not doing WebAssembly for work. I don't have WebAssembly software in production, but it's something that I enjoyed learning. And in my company, we are constantly learning new things about the cloud. And so it was amazing for me to explore these new things, this new landscape. And I think it's fascinating for all of you guys to learn something new from my perspective, which is not that of a WebAssembly developer, but a developer from full stack, from the web, full stack web, and a cloud engineer, into this new WebAssembly world, which is, I think, really amazing.
You sound very enthusiastic, and yeah, I agree. Sharing with joy or things that you enjoy are the best way to teach others. So yeah, I would say, Eduardo, without further ado, the stage is all yours.
Thank you. Okay. As I said, I'm not a WebAssembly developer, so please be aware of this when you make questions on the Q&A. I will try to share with you a journey, what I learned about WebAssembly when I first looked into it, which was fascinating because I had an idea of what WebAssembly was, and it completely changed when I started to dive deep into the WebAssembly landscape related to the cloud. And I will share what I learned with you today. I will try. My name is Eduardo. I already got introduced. As I said, now I'm a DevRel at SparFabric. SparFabric is an Italian-based consultancy firm. We do cloud-native development, custom application development. And so we are constantly trying to see what's new in the market, what's new in the cloud landscape. We are very active in the open source world and with foundations. And so WebAssembly is something that we want to keep an eye on, okay? And so my job is also to discover new things and talk about it. You can find me on social media with my handle. And if you want to contact me, Mastodon is my preferred way. So the talk today, I will talk about WebAssembly, and I try to divide this talk into 4 chapters. Let's hope we can reach the final one. I have 49 slides, but I think I have time. I will go fast. So we start with an introduction of what is my vision of WebAssembly as an abstraction layer. Then we will see what WebAssembly is, and then what WASM, which is basically an abbreviation for WebAssembly, is in the cloud. And then we see something around WebAssembly, some foundations, some projects around the WebAssembly in the outside world. And I know that every time you read something or see something about WebAssembly on the internet, most of the time it will start with this tweet by Solomon Hykes. But there's a reason for it. This is the same tweet that changed my vision of WebAssembly some years ago. When I read it first time, my opinion on WebAssembly was that of a technology that allowed software to run in a browser using the power of a computer, of the machine. For me, WebAssembly was the technology that allowed us to run video games on the browsers, okay? And it's not wrong, but it's only partial. The vision is only partial. And this tweet by Solomon Hykes, which is, of course, the founder of Docker, the creator of Docker, saying that if WebAssembly existed in 2008, he wouldn't have the need to create Docker, really changed my mind about WebAssembly. And I started digging more about it after reading this tweet. So many articles, many resources that you will find on the internet about WebAssembly will start with this tweet, and that's the reason for it. It really changed many people's perspective on WebAssembly. I want to start talking about abstractions and virtualizations, because I think the best way to describe what WebAssembly can be for the cloud and for computers in general is to talk about abstractions. In the history of computer science, we constantly tried to abstract the hardware. You know, abstractions layers are layers that we put between the hardware and ourselves as developers. Okay, we put more layers like softwares, applications layers, software layers between us and the hardware. But we want to also abstract the hardware, virtualize the hardware, because we want to run different applications and different operating systems on the same hardware. And this is a need that goes way far on the computer science history. We started implementing virtual machines and virtual operating systems back in the 50s, in the 60s with IBM. And the first formal definition of a virtual machine is this one, in this paper by Robert P. Goldberg in 1973. So way back in the 70s. It's not a young concept, okay? And you see that in his definition, Robert P. Goldberg defined 2 kinds of hypervisors. And type 2 hypervisors is the one we will use today talking about WebAssembly, which is an hypervisor that allows us to abstract the operating systems and so run different applications on the same hardware, okay? Then we made a huge step and we go to 1999, And we add another layer of abstractions, which is, it's not a new layer, but it's something that allows us to use this new abstraction layer more easily. And it's the introduction of VMware. If you were a developer at this in these years, you will certainly remember the revolution of VMware. We as developers could develop and deploy applications on different operating systems without having to have different hardwares. We can just develop on our local machine for different architectures, deploy it, packing it into a virtual image, and then deploying this image, which was like in a physical disk, because images were very large, because they contained all the files and the memory of the operating system and the applications. So we had these huge hard drives that we had to bring to the data centers and then connect physically to them. But then this changed our workflow. We changed the way we develop, adding or making it easier for us to manage this abstraction layer, this virtualization. So things changed in 1999, and things changed even more in 2013, when the same Solomon Hykes that we saw before introduced the word to Docker. This is a frame from his talk at PyCon, and with Docker, we saw that we could easily use Linux containers, which was a thing even before Docker, but Docker allowed us to manage them way easily. And then from this moment, we started changing again our workflow, because we could add another abstraction layer on top of our virtual machines and on top of our hardware. And the year after, in 2014, we were introduced to the serverless paradigm. Using AWS Lambda, which was the first serverless functions service, we could abstract even more the hardware. So we could concentrate on developing and deploying applications, and concentrate on our code and our business logic without thinking about the hardware. It's not entirely true, because we still have to think about the environment in which our application is running. We have a bit of a vendor lock-in, and still Lambdas and cloud functions in general are running in containers and on virtual machines. So it's not a complete abstraction. We have to think a bit about it. But in general, if we think of an application using a serverless approach, we don't think about the hardware, we don't think about the operating system, we think about application and logic. And so we see in this scenario, we added another abstraction layer, and we go up in these levels. And so if you look at it, we added the abstractions layer from the physical layer to our application and to ourselves, and at the same time we gained the possibility to bootstrap our application and to deploy our applications in a fraction of the time. Because with virtual machines, if we had minutes to boot a virtual machine, we wanted to keep it alive for weeks, because it took minutes to bootstrap. With serverless, if it took a fraction of a second to boot our logic, our application, then we have to keep it alive for seconds. So also the way we think about applications change, because the abstractions layer and more virtualization allows us to change the way we think about application. And so WebAssembly is the next step, I think, in this evolution. And I will try to explain why. First, let's start looking at what is WebAssembly technically. So WebAssembly, you can also say it WASM, pronounced WASM, was announced in 2015, then released in 2017, became a W3C recommendation in 2019, started as a project at Mozilla, then more companies joined, and it is an open standard and it's a binary format. We will see more about that later. And the focus of WebAssembly was to be near native in performance, to be portable and to be secure. We will see why. And I was not wrong on thinking of WebAssembly as something to run video games on browsers. I take video games as the example of a really resource-intensive application, okay, for the desktop. So being able to directly access hardware capabilities from the browser allowed us to run complex applications like video games, like 3D graphics and something more like Photoshop or Figma directly in the browser. So this was the initial concept, but this concept evolved. And thinking about something that allows us to design applications that are fast, that are portable, and that are secure may sound familiar if we are familiar with containers, because at the base, it is the same concept, okay? To be able to package an application, deploy it, ship it with all its dependencies in a way that's near native in performance. It is fast and it is secure. So how WebAssembly works? I divided three main features of WebAssembly. We have the compiler, we have the binary format, and we have the runtime. The compiler, of course, as in any programming language, the compiler is something that translates a language to another language. In the case of WebAssembly, it translates many different source languages, like the ones from the LLVM toolchain, like C, C++, Rust, or Go or JavaScript. These are recently Python. These are the source languages which are supported by the compiler, by many different compilers. And these are translated into a new language, which is the WASM binary format. And this binary format is a low-level representation of our source code. Of course, you want to have something to run this binary, and to run it, you have the runtime. So the binary format is a sequence of bytes that represents our functions, our data, our, of course, imports and exports. And everything is designed to be compact, so the bundle size is smaller, and it's something that it's really useful in a browser context, okay? We have to load less bytes, and then it's efficient. The compiler optimizes it, and it's fast. It's fast to decode, it's fast to validate. We have the runtime to execute our binary application, our compiled application. And this runtime can run our WASM application in a browser or in a JavaScript environment like Node.js, or it can be a separate runtime, like for example WASM time. WASM time was, I think, the first runtime standalone. So using this runtime in a browser, Node or standalone, we can run our WebAssembly application bytecode, so compiled in bytecode. You can think about it, if you are familiar with Java, it's the same thing. So you have Java, when you compile Java, you get the bytecode, and then the bytecode is executed by the Java virtual machine. It's more or less the same concept, okay? Through the runtime, we get access to host capabilities like the memory, the files, the network, graphics, various API from the hardware, okay? Let's keep the first demo. Let's get to this demo. Here, I will show you briefly a Rust source file, which is just a simple add function, okay, adding two parameters. I will compile it using wasmpack, which is a tool in the Rust tool chain. I get a WASM module. I can import the WASM module in JavaScript and run it. Let's see it in action. You see, this is my Rust package, okay? It's just, and it's a simple function with a bind in JavaScript, but we don't care. It's just a function that takes two parameters and returns the sum, okay? Very simple. So using wasmpack with target web, because wasmpack is a binder, okay? We compile this Rust code. We will get our WASM module and also a JavaScript that exports our WASM module from wasmpack. So we can just write a JavaScript function. This is our JavaScript function that imports our function add that we wrote in Rust. We can pass two parameters. We pass 50 and 42, and we get the result directly from the WASM module into our JavaScript, because we can import the JavaScript. Then I just wrote an HTML file, and I want to print the result in my HTML, just to show you that in a browser we can talk to a WebAssembly module that was originally written in Rust, get the result, and display it. Of course, this is a simple example. We can imagine if we have a Rust logic that encodes an image, for example, or deals with encryption or streaming, I don't know, more complex and resource-intensive application, and then get the result and display it in a browser. This is the thing that I wanted to show you. But there's more. We get WASI. I told you that we can access system capabilities, but how? Through an API, which is called WASI, which is WebAssembly System Interface. So it's designed by the WASMTime project, which is the runtime I told you before. And many operating systems features are exposed to our WebAssembly modules. For example, file systems, Berkeley sockets, the random number generator. Okay, we have many features from our local machine exposed to WebAssembly, and we can use them. But we have also sandboxing, which was one of the original design, with why WebAssembly was originally designed. We have a capability-based security, which means that when I want to access a system capability, for example, I want to access the file system, I need, as a user, as the user who runs the program, I need to explicitly allow my runtime, my application, to access that capability. And I will show you how to do that. And also in WASI Preview 2, which is the next step in the WASI iteration, we have divided the APIs into two words. We have WASI CLI for capabilities regarding files, sockets, clocks, etc. And we have WASI HTTP, which is everything regarding HTTP handling, so requests, responses, so we can manage proxies, for example. Okay. Then let's see an example of using WASMTime, using the sandboxing, so we see the capability-based features in action, with another basic example. I want to just write a Rust program that takes the content of a file and copies it to another file. That's what I want to do in Rust. So let's see, this is my Rust function, okay? And I don't know why the resolution is so low. Let me try. It's the best quality. Okay, maybe it's better. Okay, it's better. This is my Rust file, okay? And you see, it's not important, but I just take the content of a file and write the content to another file. That's my Rust function. I take the paths of the two files from the command line. So I call Rust C, because I have a WebAssembly compiler in Rust C, using WASI as target. Not important, but now I create a new file, which is hello.txt, and I call my runtime using the module that I compiled into WASM. I want to copy hello.txt to tmp/deny.txt. And you see that the runtime tells me I cannot do that. I don't have the permissions to do that. I have to explicitly allow it. So I pass the dir with the dot context. Now I can read hello.txt. I cannot read deny.txt. So I have to allow also the tmp directory to my runtime. And now I can copy the file. If I do that, I have no errors. And you can see that in deny.txt, I get my hello world. I could just copy it because I have access to the file system. I had to explicitly allow it. I want to show another thing. You see that, you know that we have the bytecode. What if we want to read the bytecode in a human readable format? There is the WAT format, it's WebAssembly text representation, and you see that you get a textual representation of the bytecode. So you will see the different functions, the parameters, it's more human readable. And you see that at the top you have the module, because every WebAssembly compiled file is called a module. And just for showing you that you can actually read the content of a bytecode compiled file using something that's easier to read for a human being. Now, you must have learned that the main features of WebAssembly are performance, portability, and security. Let's let's keep it and go to the concepts of WebAssembly. We have instructions based on a stack machine. So WebAssembly basically pushes instructions into our stack and then pops instructions, same for values and data. We have, of course, controls for altering the workflow of our program. And most importantly, we have a linear memory, which means that our program when it starts, has a contiguous array of bytes, which is fixed, but it's dynamic, so it can grow, okay? And my program is only allowed to write and read bytes from that allocated memory, okay? So it cannot write or read outside of this memory. That's memory safety, okay? If my program tries to access a byte which is outside my allocated memory, I get a trap. So my program basically crashes, okay? That's safety. And as I said, every WASM binary is a module. We have definitions and functions in these modules. We have tables, we have the linear memory, we have our vars, and everything can be exported. Definitions can be exported and imported. So we can have an application built by different modules, and modules can communicate with each other, just exporting and importing definitions. So if you now know that we can create WebAssembly modules starting from different source languages, now you know that we can create complex applications designed by microservices which are connected, and each of these services can be written in a different language. But we also need a way to let this module communicate with each other in our application. And recently, WebAssembly released the first version of a component model. And the component model is just a way to translate functions and values definitions between modules. Because again, if I can write a module in Rust and a module in JavaScript, but the values representations between of a string, for example, between Rust and JavaScript are different, then I need a way for each module to represent that string in the same way. So the component model basically wraps my module and gives me an interface so that my module can export my definition using that interface, and the other module can just read my definition using the same interface. So I get at low level, I represent values differently, but at a higher level, at component level, I see the same values, I see values using the same definitions. So these are called interfaces, and in these component modules, we have type definitions in the WASM interface type, and the way modules communicate with each other is called the canonical ABI. So we have application binary interface, okay? So basically a wrapper around modules to let them communicate. Now, a little intermission so I can drink a bit. I will leave you with a flow. Okay. Let's go with chapter 3 and see what's WASM in the cloud. Now, cloud computing is about distributed application, okay? Of course, we can have a monolithic application deployed to the cloud. We can do that, but really to get the best from the cloud environment, we want to design our application using a microservice architecture, so we can split our logic into multiple workloads. Okay, that's the best use we can do of the cloud. Now, what do we want from these cloud workloads? I think that we want efficiency. We want flexibility, scalability, and security. And WebAssembly, as a runtime for our cloud workloads, offers efficiency because it's, as we saw, it's compact, it's optimized by a just-in-time compiler. It's flexible because I can write in many different source languages, and so I can communicate with different people, different teams, and my logic is distributed. it scales efficiently because we have modules that can run independently. So we can have horizontal scaling because each module is independent. So we can efficiently scale. And then for security, we have the best of security because we have sandboxing and we have memory safety. And the isolation of each module ensures that I have that a module cannot access other modules' memory or the memory of my machine for other applications. So it's the best I can get from a security perspective in a cloud workload. There are already cloud workloads available in a cloud that you can try right now. I will tell you about two of them. The first one is Fermion Cloud. Fermion is a company which designed the Helm package manager, and they created Crustlet, which is a kubelet for running Wasm time workloads. But they offer these capabilities with Fermion Cloud. With Fermion Cloud, you have serverless functions enabled as Wasm workloads. And with Spin, you have an SDK and a CLI to deploy these Wasm workloads. And recently, at KubeCon, they released SpinCube, and we will talk about it later. Another company that offers serverless Wasm serverless is Cloudflare. With Cloudflare Workers, you have a platform for deploying serverless functions as Wasm module. And it's not based on containers or virtual machines, but on a features of V8, of the V8 engine, which is isolates. Isolates are basically context, basically a grouping of variables and functions, okay? And so you cannot from a single module, you cannot access the modules from another isolate, okay? So a single V8 process can run thousands of isolate without letting each one of them interacting with the other, okay? So you can scale horizontally. And that's the feature the Cloudflare workers use. And I will show you a quick demo of Cloudflare. If you're familiar with Cloudflare, you use Wrangler to create a new project. So you can generate a new project using a template. You see that worker Rust is a template. So I created this project with a template. Now, inside my project, I have my Rust package. I changed the name, just the name. And in my Rust function, I see that I just managed the HTTP. I print as a response in HTTP a new string. Hello, attendees of my talk, okay? So my function will answer me with this response. Now I just call Wrangler deploy. And Wrangler calls the Webpack, the Wasm pack, sorry, and compiles my Rust to a Wasm module, as we saw before, and then has the responsibility of taking my module and deploying it to Cloudflare Cloud, okay, to the worker. So now you see that it gets compiled and uploaded. I get a URL, and if I click on this URL, it is responding. My function is responding with the response that I expected. I hope I have deactivated this function. Now let's talk about some other project. This is Wasm Edge. And I talked to you about Wasm Time, which is a Wasm runtime. Now Wasm Edge is another Wasm runtime, which is especially designed for cloud, to be run in the cloud. And is a project developed by Second State, and officially is a CNCF sandbox project. Wasm Edge is important because it's what Docker use to run WebAssembly. How? Well, Docker collaborated with Wasm Edge to create a containerd shim. To understand how it works, you get to understand how Docker works. So you have the Docker, the user interface, okay, of Docker that allows you to communicate with the Docker engine. Then the Docker engine communicates with the containerd runtime, the containerd process, okay, and the containerd process have to communicate your instructions to the container runtime. So you tell Docker to spin up a container, to stop a container, these instructions is passed by containerd to the container runtime, which is runc usually. Okay, so you have runc to physically handle containers. For containerd to communicate the instructions to runc, you have a shim, which is the containerd shim. Okay, now if you want another runtime, so you don't want runc, because runc runs containers. You want to run WASM modules. So you want to substitute runc with the WASM runtime. We have the WASM runtime, which is WASM Edge. Now we need a shim to let containerd communicate with WASM Edge. And this shim is containerd WASM shim, which is a project based on Run WASI, which is another initiative with contributions from Docker, Second State, Microsoft, and others. And then we have a shim for containerd that allows us to communicate with WASM Edge or other runtimes, for example, Spin or Slide or WASM Time or others. So now we have Docker and we see our Docker containers, but also our WASM modules. For us, they're the same thing. We just need a way to define it and to run it. We have the runtime. The definition is just a Docker image. You see that you write a Docker file, just copying your WASM module into the image, and then using Docker to build this image. You just use buildx with the platform WASI WASM flag, and then you tag it, so whatever you want. So you build this image, and then you can push it to the registry. It's not a Docker container, a Docker image. It's a WASM module inside a Docker file. So now you can have this image and you can run this image, which is a WASM module, in Kubernetes, because Kubernetes uses containerd. So on a pod, you can switch the runtime and you write a new runtime class. In this example, you see the wasm1.yaml is a new runtime class. I used the wasm time as a handler. I could use anything, but I used the wasm time. You see the source example, but I will show the slides later. Well, then you have a new runtime class with wasm time, and in your pod definition, you use this runtime class as a runtime class name. You see, wasm1. And then the container is the container you pushed before, the module with the username hello world that you pushed before. So for Kubernetes, for the pod, it's just another image, but containerd is using a different runtime, and it's the same that we saw before with Docker. We have a containerd shim, which is running wasm time as a runtime, and then we can run our wasm. We can have also wasm as another shim and run another wasm module. So that's the way we have wasm module in Kubernetes, same as and at the same level as container images, just using another shim and switching the runtime from runc to wasm. Now, I told you before about SpinCube briefly. SpinCube is a new open source project. It was presented by Fermion at the KubeCon. It's a CNCF sandboxed project. And this basically simplifies for you the process of adding a WASM module to Kubernetes, because you need many things. You have many configurations. But with SpinCube, you have the containerd shim with Spin, you have the runtime class manager, you have a plugin for Kubernetes, and you have the operator. So this simplifies the deployment of a WASM module in Kubernetes. I didn't try it, but I see the talk, and it's a way of thinking of a cloud in which you can use transparently Docker images or OCIs and WASM modules for your workloads independently, okay? And another little example that I wanted to give you is with traffic, because traffic is, of course, an ingress control, an ingress for Kubernetes, an API gateway is a proxy, a reverse proxy. It's interesting because traffic is written in Go, and traffic allows you to write plugins, okay, for handling HTTP requests and responses. With version 3.0, they enabled WebAssembly support. That means that traffic can run WebAssembly modules as plugins, which means that you can write a plugin for traffic, in other languages, not just Go. You can write a plugin in Rust, in JavaScript, in C++. You just have to compile it to WebAssembly and load it as a traffic plugin. So now you have your traffic with different plugins written in different source languages. And this is, I think, a hint of a future of modular application development. So an application which is written and composed by different parts, different modules, written in different source languages. So for example, you have an application and you have a team that's proficient in JavaScript, another team that's proficient in Rust or Go, and then you write different modules for the same applications. All are compiled in WebAssembly. And then with the component module, each module can export functions and values and import them from another module. You have an application, modular, and written in different languages as a source. So that's maybe a future of application development. So we are now at the final chapter. So let's see WASM in the world. We have the scenario is not simple, okay? Because I told you at the beginning that WebAssembly is W3C recommendations, which is correct. In W3C, we have WebAssembly working group, and the purpose of WebAssembly working group is to standardize the format. Okay, so the WebAssembly language, the format, is defined by a standard, and the W3C is working on it. So you see the W3C recommendation here, and you can join the working group to see the evolution of the language. But it's not, we don't have only the W3C, we also have the Bytecode Alliance. The Bytecode Alliance is a new organization, a new foundation dedicated to WebAssembly and everything that's around WebAssembly. For example, they trying to standardize WASI, so the system interface, okay, and it includes projects like runtimes, like WasmTime, and other projects, other runtimes like CraneLift, WAMR, etc. So in these associations, which comprise many members like Amazon, Docker, Microsoft, etc., you find a home for various projects around WebAssembly. So various runtimes, the component module, for example, module definition, etc. So you see that now we have two subjects in this landscape. We have the W3C and we have the Bytecode Alliance. But that's not all, because we also have the CNCF. In CNCF, we have a dedicated landscape for WebAssembly. I already said that we have SpinCube in CNCF, but we also have WASM Edge, other runtimes dedicated to the cloud, and other WebAssembly projects. You see the landscape is already populating, okay? We have many projects and we are growing. So in CNCF, we have other WebAssembly projects and other in Sandbox, which are coming. Okay, so 3 subjects at minimum for the complexity of the world around WebAssembly. So the W3C is handling the definition of the language, the Bytecode Alliance, what's regarding the system interface and the way we are using the runtimes, and the CNCF for projects regarding WebAssembly in the cloud. Now, if you're interested, there's a document from /data collected in this link, a report. It's the State of WebAssembly 2023. And of course, is a document that gives you an idea of WebAssembly usage in the world. One of the interesting part is this one, is a survey. What is WebAssembly used for? You see, the first one, of course, is web application. Right now in production, you see many web applications using WebAssembly. Most popular, I think, are Photoshop and Figma. But if you look at the bottom, you see that serverless, it's 14%, and it's destined to grow, I think. So we have already a 14% of the total of the WebAssembly projects in the world used for serverless applications and capabilities. And I think this year, next year, this number is destined to grow. So the WebAssembly usage and adoption in the cloud, I think, is destined to grow. So these are my conclusions. So we saw that WebAssembly is a fast, portable, and secure binary format. WASM can be used in the cloud as a replacement for container or in parallel with containers, alongside them. We can use WebAssembly for edge computing. We saw that with Cloudflare Workers, okay? It's supported by various projects and initiatives in the cloud, such as Cloudflare, WASM Edge, Fermion, and others. And we know that WASM is part of the W3C, the CNCF, and the Bytecode Alliance, which promote the standard, the adoption, and the collaboration around the WebAssembly world. So that's it. Thank you for listening to my Italian accent. I am perfectly on time, I think. And in this QR, you will find the link for this slide, for the public version of this slide, so you can go through them without my voice and with many links that I shared. Again, I am Eduardo. You will find me on social media with Edoduzzi or on Mastodon. This is my handle. I also have a YouTube channel and a podcast, but it's in Italian, so I think it's not for the majority of this audience. So thank you very much, and I'm done.
Hello again, Eduardo. And thank
Hello.
you so much for sharing all this with you in your magnificent Italian accent. It makes
Thank
everything
you.
sound like music. It was like a symphony.
Okay, thank you.
All right, Eduardo. We got some questions from the audience, and if you're ready, we could
Sure.
dive right into them. First question, yeah, stay hydrated. Very good.
Yeah.
How well does WebAssembly work with tools like Docker? Are there any challenges with integration, or is it pretty seamless?
Okay, in my experience, it's pretty seamless, but it's an experimental feature. So you have to enable the containerd image store, which is, I think, again, experimental, and then you have to enable WASM support in Docker for Docker desktop. Okay, and once you enable them, you just write a Docker file with a WASM module inside and run it building it with a target WASI, and then you run it with Docker or with Kubernetes just seamless. So it's really easy to get started, but since it's experimental, things can change, things can break. This thing is valid for all WebAssembly, I think, because if you saw my slides, for WASI, for example, we are on the preview 2, which means basically we are something around 0.2 for the recommendation, for the definition. WebAssembly itself is not, it's constantly changing and evolving, so maybe things can change and break. But right now, if you want to try it with Docker, you just follow the guide on the Docker documentation, and it's just one page. You change the OCI store, and you enable WebAssembly, and you're done. It's really easy.
Step-by-step instructions. Perfect.
Yes.
Love them. All right. Thank you for your answer. Let's tackle the next question. What makes WebAssembly a good choice for scaling cloud application on demand? Are there any limitations to its scaling capabilities that we should know about?
Of course, I think it depends on your needs and your scenario. Of course, the great advantage we have with WebAssembly is the boot time, because even starting cold, we have a fraction of the time that we need to spin up, for example, a Lambda function. Okay, a fraction of a Lambda function. So in order to spin up a WASM module, we just need the fraction of the time that we need to spin up a Lambda function. So scaling, it's easier. Well, designing something that scales, spinning up other modules, it's easier to think about it because we can take away the problem of the cold startup. Okay, because we have we have a module that spins up in milliseconds. Okay, so we take away this issue, and I don't think there are limitations. The limits are in what WebAssembly supports right now, because we have many capabilities. We have file systems, we have the network, but we don't have everything. So if you have to write something that relies, for example, on the POSIX API, WebAssembly doesn't support the entirety of the POSIX API. So you cannot design so maybe you cannot design or port your application entirely to WebAssembly if it relies on something that WebAssembly doesn't support yet. I think this is the main concern that I have. For everything else, you get something that's like having serverless functions, but way faster and more secure. So that's my opinion. I didn't try it in production, but from what I saw, this is the opinion that I can share with you.
Right. Thank you. Next question. Do you think WebAssembly might eventually replace traditional cloud services, or is it more likely to complement them?
Yes. This is the same question that many asked to Solomon Hykes, of course. And I think the answer is first of all, we don't know the answer because we don't know what will be tomorrow in 10 years. We don't know the cloud world. But from what we see now, WebAssembly is not ready to replace a cloud service with Docker image, with OCI container. It's not its purpose. And again, because WebAssembly doesn't support everything that Docker supports right now. We don't have many APIs that we need. And also, we don't support many languages. So WebAssembly, you can compile many languages into WebAssembly. You can compile the LLVM, toolchain, JavaScript, but you don't have many others. You don't have Java, you don't have PHP for now. You can compile the interpreter, but it's not. So you don't have all the languages that you need. So you need containers for that. And also, in containers, you can pack every dependency that you need. So if your application needs, I don't know, CURL or another dependency, which is an operating system, if you don't have support for it in WebAssembly, you cannot pack it with your module. So you're limited. So again, it's not meant as a replacement, but you can use it alongside your containers. For example, if you have an application and a single function, a single part of your application is dedicated to encoding a file or do something with cryptography, then this specific function, you can write it in WebAssembly. You can use a WebAssembly module, but the rest of your application can simply rely on Docker containers. So I think the best scenario right now is to mix them, Docker, OCI containers, and WebAssembly modules.
Seems like you could have an entire talk about this topic. So yeah,
I think so.
Let's brainstorm on this. All right, thank you, Eduardo. And we jump to the next question. Does using WebAssembly in the cloud lead to cost savings or better resource utilization?
Of course, this is the selling point of WebAssembly I see in many cloud services, in Fermion, for example. So if you pay for the time that you use a service, of course, you have a faster bootstrap startup time. Okay, so you pay less because you are using less time, so you're paying less for this. And as a resource utilization, I don't know, regarding time, of course you have less time. For resources, it depends on the design of your application. If your application needs to allocate gigabytes of memory, you pay for your memory. So the resource utilization, I think more or less are the same. And the resource utilization it depends on how you design your application, not on the runtime. Okay, this is more or less my opinion. Of course, if you write just a simple function, for just a function like the examples that we see, if you have to sum two numbers, okay, simple function in Rust, you get a WebAssembly module. To run this module, so the cloud just need a runtime, WebAssembly runtime. For, I don't know, a Lambda, they need Docker containers and virtual machines. So if you compare the costs of the two, you get better savings with WebAssembly. But it really depends on how you design your application, I think, for resources.
All right. Thank you for giving us insights on this as well. So next question, let's take this one. What do you think is next for WebAssembly in cloud computing? Are there any trends on the horizon?
Well, I see that they are advancing the WASI, so the system interfaces. They are adding more and more system capabilities. So now we are handling many hardware resources. We want to add more, and also in the HTTP world, we want to add more capabilities. Okay, so the future will be to have way more capabilities and have more access to external functions. Okay, and this is one thing. Other things would be to improve the support for languages. For example, now WebAssembly was born supporting linear memory, okay, and specific languages which uses linear memory like C or Rust or Go. But now we want to also support garbage collected languages, and which is why, for example, I think the team in Chromium, they developed a garbage collector for WASM, for the compiler, for a WASM compiler, so that we can support also garbage collected languages. And that's why I think they are starting to release compilers that support garbage collected languages, just Python, for example. I maybe think they will support PHP or Java in the end. So I think the next trend would be to have more support for more languages, to improve performances, and also everything related to accessing external capabilities like the network and the host file system and hardware.
Right. Thank you, Eduardo. We still have time. So let's tackle the next question. How does WebAssembly fit into the context of edge computing? Does it offer any advantages for running applications closer to where they are needed?
I like this because if you think of the edge, you can think of the edge computer as servers that are close to your home, but also devices that are close to your home you are using. Okay, and since you have different architectures for different devices, different servers, with WebAssembly you just have one architecture. So you can design your app, your software, your application for one architecture, which is WebAssembly, and ignoring what's below it. Okay, you just have a runtime. You don't have ARM, you don't have RISC-V, you don't have x86. You just have WebAssembly. So in designing an application for the edge, it gets simpler because we have only one runtime, and the runtime is a tiny runtime. We don't need many dependencies for running just WebAssembly. Okay. Instead, if we want to run a Docker container or a virtual machine, we need a full operating system, and a full operating system takes space and takes resources. So even if we have a Raspberry Pi or a tiny server on the edge, that server needs to run an operating system, and it's big on resource consumption. With WebAssembly, it gets smaller because it just needs to run a WebAssembly runtime, which is smaller. And so this is, I think, one big advantage that WebAssembly has as a runtime on the edge. And another one is security. You saw in the news many things related to the security of edge computing. We have many many devices, appliances exposed to the internet, which are constantly broken by bugs, bugs that introduces backdoors. We saw very recently something regarding these scenarios, and most of them are related to the memory, to the fact that languages used in those contexts are not memory safe, which are C, C++ most of the time. But WebAssembly is memory safe, is designed to be safe and memory safe. It's memory safe by design. So you take away all this attack surface for your in your edge. So security, performance, costs. Really, WebAssembly has a big advantage on edge computing, I think.
So basically a no-brainer.
Yes, I think so.
Yeah. Perfect. Eduardo, before we close the session, would you mind me asking, you are an experienced developer, you're a content creator, you're dipping now in DevRel. How did you start to become interested in tech, and like, what were the steps that led you where you are now?
Well, I don't remember. Yeah, I don't. I don't remember being not interested in tech because I was always interested in tech. When I was a kid, when I was a child, I started typing on little things. There's a thing in Italy, we call it grillo parlante. I don't know what's called. It's a Texas Instruments device, colored device with a keyboard and a small screen. So in the 80s, it was a big thing in Italy. So it basically a small computer, and I started with this when I was, 3-4 years old. Then I started typing on an IBM, an Olivetti with an Intel, 286, and then from there I never stopped. I was constantly looking for more hardware, more software, more things to get my hands on, and it never stopped. So always.
All right. So it was a very organic journey for you to just get into as many tech roles as possible.
Exactly.
But,
yes.
Yeah, you're certainly very enthusiastic when you talk about all this stuff. So very happy. So Eduardo, then thank you so much for your talk. It was a pleasure having you today. It was very informative, and thank you also for the Q&A. You shed some light on some very interesting topics also there. And yeah, let's have a look on your next topic. Maybe we will see each other on another.
Sure.
topic.
Thank you for having me. Bye-bye.
Bye. All right, and we jump right to the next speaker of the day. He's Director of Developer Experience at Red Hat. He is a Java champion, contributed to many books and publications, and he's a strong believer in the open source software model. Very welcome, Alex.
Hello, good afternoon. I was thinking like, now it's a good afternoon, It always happens this to me that I don't know if it's good afternoon, good morning, you never know when it changes from morning to afternoon. So like, now it's... So good
That's
afternoon.
True. Yeah, yet at ours it's 1 p.m.
Yeah, exactly. So it's afternoon, yeah. Okay, so yes.
Perfect. So Alex, thanks for joining. We are happy that you are here. Before we jump into your talk, would you mind sharing 1 or 2 sentences with the audience and me about what we're going to learn from you today?
Yeah, sure. Yeah, today what we're going to learn is about, we have been listening a lot about hybrid cloud, but it seems like, probably it's super complicated, right, to do this kind of hybrid cloud. And we'll see today that, well, that's not so complicated if it's done right, okay? And we are only going to see using open source technologies. So there is no excuses to not embrace hybrid cloud because all is free software.
Perfect. That sounds awesome, Alex. I'm looking very much forward to your talk. And without further ado, I would say stages are yours.
Thank you very much. So yes, let us start, as I mentioned it, of how we can embrace this hybrid cloud by using only open source technology, right? Because, well, maybe you're already doing hybrid cloud, but probably you are doing hybrid cloud from the point of view of operations. Okay, and what I'm just going to try to show you here is that you can do hybrid cloud, but from the point of view of developers. So since I'm a developer, I tend to think that things that are done for developers by developers are easier to understand than ones of like for the ops team. Okay, so let's think about a bit of why we need hybrid cloud, because basically nowadays big organizations has a a diverse of different environments. Maybe they are using Amazon, maybe they're using Azure, maybe they're using Google Cloud. I don't know. They are using some kind of cloud. Depending on your business, maybe you also have some kind of edge environments, maybe also some kind of on-prem, like for example, I don't know, the data center has the databases with all your data is on-prem on in your building, but the backends or the front ends are on the public cloud, and yeah, maybe you are using also some kind of IBM alt stuff if you are a bank, right? So it's a lot of diverse or different environments where all these environments confirms the application. And the problem, of course, is that you need to connect all these environments, because at the end, all the applications that you are developing, some of the small pieces are running on Amazon, maybe other small pieces in cloud, Google Cloud, maybe others on-prem, and so on. So you've got all your services, all your products in different environments, and you need to interconnect. So that's one problem, how we interconnect all these environments together. The second problem is that, okay, and we need to do it in a secure way, because we do not want to compromise the infrastructure of data. So it's not just connecting all the, let's say, clouds, environments, and so on. It's not only this, but also make it secure. So if there is, any data leak somewhere, or any attacker tries to, sniff data from here, he cannot or leak any information. Okay, so some simple questions, but not necessarily simple answers on this kind of environments. The first one is, are you struggling to connect your application together across hybrid environments? Okay, and maybe now you're thinking like, oh yes, but I don't only use one cloud, and that's fine. But then comes the other question: is, are you only using one region or multiple regions? Maybe. Are you struggling to connect these multiple regions? Or maybe usually you might have dual data centers. There are some organizations that has dual data centers. If one data center goes down, then they have another one. How you interconnect these two data centers? Or maybe you've got a lot of edge, right, devices there that it's also into your cloud. How you interconnect all these elements? You do it, it's easy or not? Then, are you struggling on getting your cloud application securely connected? As I said, okay, I've got one part of my application that is in the cloud, other than maybe it's on-prem, maybe other it's a legacy application. And can you connect it securely between them? Especially, of course, if you are doing a greenfield development, probably you're using the latest and greatest techniques for securing your application. But what's happened with the legacy? How you can secure this legacy communication? Yeah, maybe you're struggling, maybe not. Or maybe you're not struggling, but you're doing things really, really complicated to make it work. There is another option or another problem. And I know that maybe for some of you, it's like, oh, this is not going to happen. But trust me, I live it this once. And it's, how are you dealing with cloud migration? I remember that one of our customers said, hey, look, we were in Amazon, okay? We've got everything in Amazon cloud, but because of, management decision, we need to migrate from AWS to Microsoft Azure. How are you dealing with this kind of cloud migrations? It's a big bang of concern. So you just take your workloads from Amazon and you move it to Azure, and let's see what's happened. Yeah, of course, this is an option. but maybe it's not the best option, right? So is a Big Bang a concern? Yeah, if it's a concern, then this what we're going to, or what I'm going to show you, it's important. Again, are you worried about locking? Maybe you are fine using just the cloud services that your cloud provider offers, but maybe you're thinking more about in terms of cloud portability. If this is a concern, then I think that I will find you a great solution today. And of course, there is another problem that you might face, and is what's happened if I've got, a spike of traffic. But when I'm saying a spike of traffic, I'm not saying doubling the traffic. I'm maybe saying like, that's 10 times the traffic, because maybe it's on, the sales, it's a sales time where, it's maybe Christmas, and you get, when a spike of traffic selling a lot of content because you're in, a super nice electronic shopping, right? And you need to sell a lot. How you manage this? Or what's happened if the cloud where you are deploying your application is down? I remember not a long time ago this problem with S3, right? That S3 went down, and okay, most of the websites went down as well, right? How do you manage these kind of things? This is why hybrid cloud is important, and more important is solve the hybrid cloud problem with open source technology. So we are going to talk about connectivity, about portability, and about scaling. Okay, so different choices. There is a lot of different ways to do that. First one, for example, is just using public IPs. Okay, you've got all your, here, for example, I've got my public cluster, and here I've got my private cloud, data center, wherever, how you connect it. Okay, yeah, you can use, for example, with public IPs. Put here a public IP, here a public IP, it works, that's true. Problem is that, okay, each IP is a cost. There is no network isolation because everything is private. And okay, if you are starting putting some nets or firewalls, then the connectivity might be a bit complicated. And then you might say, oh, no worries, I'm going to just set up an VPN. It works, but because it offers you a network isolation, but trust me, you're going to increase your complexity a lot. Probably some days you will start getting some kind of connectivity errors because of, I don't know, any new rule that has been added to, for example, the firewall of the VPN or whatever, and you require an administrator to manage all these things. And remember that I said at the beginning that for me as a developer, I want to be the technology be developer friendly, and a VPN is not a developer friendly at all. Of course, you can use any of the network providers that offers the cloud providers, but it's a vendor locking, so it's fine. But it just maybe works if you're using Amazon. But if you want to connect the Amazon cloud with the Azure cloud, yeah, maybe then you've got some kind of problems. It's a solution, it works, but again, keep in mind the cost, and also you requires cluster privileges. So what is for me the best solution in most of the cases? Of course, as usually, it's my personal opinion, and it's in most of the cases. It's this, like some people say, hey, should I use this or that? I usually say, well, depends on, right? That's the thing. Okay, and it's using Scupper. Scupper basically, we'll see, is an open source project that uses the overlay network approach. So basically, it's not something that is in the network level, but it's at, if you will, at application level. Okay, since it's an application level, it's controlled by the developer. You'll see that it's no complexity. You're going to really understand clearly what Scupper does. If I ask you, hey, how the VPNs works under the covers, maybe some of you knows, but probably most of you say, I don't know, it creates a tunnel, and well, some keys here and there, and then, oh, look, we are all in the same IP range, right? That there is something like a black box. In the case of a Scupper, it's really clear what it does. And it's really a very low cost for the adding Scupper in terms of money, in terms of cloud usage. So that's the solution we're going to explore. A scupper basically lets you, in a simple way, secure the application connectivity across platforms, clusters, or clouds. And its main focus on improving these 4 columns. The first one is the application connectivity. We want to connect applications, and we want to do it securely, without VPNs or without doing weird things, right, or complicated things. Just I want to connect application A that is in cloud A to application B that is in cloud B. I just want to connect them. If you're able to do TCP calls, that's fine. Just connect it. The second thing is that security is the most important thing. So when you are using a scupper, by default, without doing nothing, you are secure. So it's using MTLS to communicate both of the applications, even though they are in different clouds, even though you have not configured the network. Doesn't matter. The encryption is granted. Okay. Then another thing that I really love about the scupper is that it's an application layer abstraction. It means that as a developer, I don't care if it's an IPv4, IPv6, if I don't know if the network is a cable or it's a wireless, or I don't care. I just want to connect to applications. The rest, it's communication. I'm a developer. It's okay in any way. And finally, and that's the key point of a scupper, is that it works at layer 7. So it means that we are working at application level. And this has a really good advantage of other solutions. When you are working at layer 7, it means that it just works as any other application. So we do not need a special rules. We do not need a special firewall or IP tables rules. You don't need to understand the network stack, just the level 7. Okay, we do not need to do anything special, just works. You will see it in the demo that I'm doing nothing special and it works. Then how scupper works under the covers? How is the, if you will, the architecture of a scupper? Let's suppose that we've got this scenario. We are an organization and we've got these H devices. It can be one device, can be multiple devices. I don't know. Suppose that you are a transport organization and you've got all your buses around the city. So each of these bus is can be considered as an H, if you will. And maybe you're running into a virtual machine, or maybe into a container engine like Podman. Doesn't matter. Okay. Then I've got the public. I've got my public cloud. There, I'm just having some kind of other applications running in my public cloud. Can be Amazon, can be Azure, wherever. It's your public cloud. And also, we've got a data center. This data center, maybe it's just something that you've got on-prem, and where you are storing all the data. It could be an application, it could be a database. It doesn't matter. Okay, it's just an application. As I said, if these applications works with TCP, they work with scupper. So a database that uses TCP, yes, okay, then you've got it, the database here. Oh, this is an application that uses TCP, yes, it works as well. Okay, then you got this and you want to interconnect all these pieces together. See that they are in different places. These are maybe your buses that are moving around the city. This maybe is in Amazon, in any region, and this is maybe in your building. Then what we're going to do is create a service, right? A service, in this case, you can imagine as an it's like a Kubernetes service that makes connection to this application. That's the first thing that we're going to do. And then we're going to install this SI router. Okay, this router is something that is installed by Scupper. And don't think about a complicated thing. It's just a pod. Okay, it's a pod that is running a scupper, and basically it just collects all the network information that it needs. But again, it's just a pod. Of course, you can run it outside of Kubernetes, but in most of the cases, you run it inside Kubernetes, and it's just a pod. Nothing complicated, nothing that you need to install. You do not need admin privileges to run this router because it's just a pod. In fact, you'll see in the demo that I'm just running in 2 clusters, and in both of the clusters, I'm not the administrator, and it works. Then, if I want to connect this data center with this public cloud, I need also to install a scupper in this public cloud. So basically, I'm saying, hey, install the scupper router in this cluster. Again, nothing complicated, just a pod running here. And now, at this point, we've got a communication, let's say a direct connection between this router, so between the data center and the public cloud. And it's done using TCP over MQP. And as I said here, with TLS. So the communication is secure, and it's using AMQP protocol. Basically, to not get into more details, the MQP protocol, it's a level 7 protocol that lets you, maintain connections between 2 hosts, and it's really important that these connections are bidirectional. So when I did this link, basically I can send packages from this router to this router, or I can initialize a connection from this router to this other router. So the connection is bidirectional. Great. Now we've got this direct connection. What else? Okay, now at this point, I can do some kind of data flow. So I can just send level 7 packages, for example, HTML, REST, content, wherever, from this cloud to this other cloud. In this case, it can be an on-prem cloud or not. Okay, then this is where the magic of a scupper comes. I've got here my application, I've got the routers, and the next thing that I'm going to create here, in this case, is scupper will create automatically a virtual service. If you are in Kubernetes, it's a Kubernetes service, and a standard Kubernetes service. It's not a special service. It's not a special element on Kubernetes. No, it's a Kubernetes service, but it's virtual. Why? Because this service is not pointing to any application. It's pointing to this scupper router. Then, every time that this application sends a request to this virtual service, as any other virtual service, just using the name of the service, port 8080, whatever. So just standard Kubernetes service will automatically redirect the traffic into this application. So from the point of view of this application, my application, he will never know that the request goes to another cloud. This application will just send a request to a Kubernetes service, and automatically this Kubernetes service will send or redirect the request to the router. This scupper router will send it here to this other scupper router, and then send the request to the application. You see that are different clouds, but the application will never know that. And of course, we can just do the same in the edge, or in the edge computing, the VM computing. In this case, depending on the environment, this router will be different. Let's suppose that you're running Podman in each of your device, right? Your edge device. And then this will be a container. And of course, we will make the connection again between this and this. And at this point, since I've got a connection from here to here and another connection from here to here, all these edge applications can communicate with the public cloud, but also with the data center. So basically what I'm saying here is that my application will have a virtual service that when my application, remember that this application might be running in each of the buses that I've got around the city, when it sends a request to this service, automatically, magically, the request will be sent, for example, to this application. Okay, so what I want you to get from here is that you do not need to do anything to your application. It just works. A scapper will take care of everything. Then, how to do that in 4 easy steps? Let's suppose that we've got this. I've got, for example, my laptop, because a scapper even can work for connecting your laptop to any other cloud. So I've got my laptop. I've got a public cluster, and I've got a private cluster. Why not, right? And I want to connect my laptop to the private cluster. Of course, I could do an SSH, or I could do, a VPN. Yeah, I can do all these kind of things. But remember that this requires, it's not really developer friendly. And I want to be developer friendly. So I'm going to use a scapper. So the first thing that I'm going to do is this. A scapper init. A scapper is a CLI tool that when you run it on your, for example, Kubernetes cluster, you've got your Kubernetes cluster, you do scapper init, and it will install these routers, the scapper routers. Okay? Remember, in most of the cases, it's just a pod. Then I need to create a token. Why? Because remember that I said that I want to secure all the communication. So I need to have a token to secure all this communication. So I'm just going here, for example, in the public cloud, and I will do scapper token create, and I will store the token into a file. So at this point, what I've got is a token here. Next step, scapper link to each of the clusters. In this cases, basically what I'm doing is transferring all the tokens to the other clusters. I created here, so I need to send this token to my laptop. I need to send this token to the private cluster and create the link. Basically, here is where I configure all the, all the network. Okay, with just this simple command. Finally, and this is something that it's really important to keep in mind, is that by default, a scapper will never expose any service running in any of the clusters. It means that if you do nothing, then this service will never be able to talk with this service or with this other service. For security purposes, of course. So by default, none of the services are available on this service network. What you need to do is do an scapper expose and set which service do you want to expose. Okay, so basically you're saying, look, I've got here a service, and this service I want to be available on the other clouds. Then you need to expose it. And after that, each of these clusters will be able to send requests to this service, okay, transparently. And of course, with MTLS. So let me show you this demo, okay, before we get more slides, but just so you can see it. This is my cluster. Wait, let me see if I'm logged or not. I think that I'm not logged. Oh, yes, no, let's see. Okay, this is one cluster. Okay, this is a Kubernetes cluster that is running on GCP. Okay, so Google Cloud. You can see here that I've got an application which is my front end and an application that is a backend. So this is my application. And then here you see the scapper router. Okay, of course, here I've got other pieces installed, like for example, Prometheus to expose metrics and things like that. Here, for example, is the scapper service controller. But the important point here is the scapper router. And I want you to see that it's just a pod. You click it here, you see that this is a pod. You can just check the logs, and here is all the logs of everything. Okay, so this is my application. Let me go here again. My application, as I said, it has a front end and it has a back end. And then I've got another cloud which is another Kubernetes cluster which is here. You see that in this case, I'm not using Prometheus. And again, I've got here a backend. It's exactly the same backend that I've got it here. So it's, it's not the same instance, but it's the same image. So I've got my backend deployed in Amazon, and I've got my backend deployed on Google Cloud. I've got front end and then two backends, one in Google Cloud, another one in Amazon. Now, let's go to the front end. This is the front end of the application. And I'm going here to say, for example, hello. I'm going to send from the front end a hello to the backend. And I send request, and you see that it says, oh, look, this is the pod, and it says aloha, hello. This is the response. And you see here, this is the cloud that processed the request. And you see that it was processed by GCP, which is this one. I can do, for example, here, hi. And I send the request, and again, it's GCP. I could say, I don't know, hola. And again, it's for GCP. But now, what's happened if I go here? Notice that I'm not changing the front end. The front end is still the same. And I'm going here, and I'm going to simulate a failure on the backend of the Google Cloud backend. Now I've just scaled it to 0, but you can think that, okay, yeah, something's happening, and this pod just goes down, and I cannot recover, wherever. Now I'm going here. See that I'm not changing the front end, I'm not changing anything, and I'm going to say goodbye. And I send it. Now, I'm still getting the response, but it's coming from Amazon. You see, I could just here say bye. Adios. And it goes all the time to Amazon. And I'm not changing anything. Automatically, Scapper has detected that there was an error on the backend of GCP and decided to reroute the content to the other site. In this case, is Amazon. Of course, what's happening if finally, sorry, this comes to the live? I can go here and I can say, I am back. And now I'm going to GCP again. And maybe you're wondering, why by default goes to GCP? And if not, it goes to Amazon. Super easy. Because Scappers have some policies installed. And in this case, it's saying, well, what is less expensive? Doing a request to the same cloud or to an external cloud? Oh yeah, it's less expensive doing it in the same cloud. So I'm just going to do the request to the same cloud. But what's happening if this same cloud is down? Okay, then I will need to redirect automatically to another cloud, which in this case is the one that they've got in Amazon. Scapper also comes with, with this great, you see these great images. You see, this is one cluster, this is another cluster. You can, get all the services that there are here. You can even see all the traffic between clouds, the latencies as well. All the sites you see that you can see that they have the hybrid, which is the Google Cloud, and also you see here that this is the Amazon. Okay, you can just check it here. You see all the traffic that is happening between the sites, all the components, and so on. So also Scapper comes with this UI. Okay, now let me show you another thing before we get back to the slides. If I go here to the networking in services, you see that I've got this hybrid cloud backend. And then I have got here some other services. But the important part here is this hybrid cloud backend. This service, okay, it's not a simple service. It's not a service that has been created to communicate with a pod that is running on my namespace. It's a service, okay, it's a Kubernetes service that, as you can see here, is annotated. Let me check it. Here. You see that it says pod selector application Scapper router. So it means that every time that I send a request to hybrid cloud backend service in port 8080, It's not sending the traffic directly to the backend. It's sending the traffic to the scupper router. And then the scupper router will say, hey, you're sending me a request from the front end to a backend. What is the best backend here now? It's the one that is running on my cloud? Yes. Then I redirect the traffic to that instance. No, because it's down. Okay, then I redirect to the other backend, the other backend that is running in the other cloud. And you can see that happens transparently to the developer. Developer just created the front end and just put it a URL. And it's a scupper who will redirect the traffic. And as you can see, transparently, no complicated things. It's just a pod, nothing else. And as you've seen in the slides, just scupper init, scupper link, and then scupper expose, of course, and done. Just 3 commands. And you've got all these created. Of course, you can make it you can reproduce this demo in here. This is the link, Red Hat Developers Demos /hybrid cloud. And you can reproduce this in, I don't know, in 2 clouds, or even it works in your Minikube and a public cloud as well. So the protocol lets you also communicate with local machines, even though you do not have an static IP. Okay, so feel free to play in this. There is the instructions where it explains you how to do all these things. So what you've seen, first of all, it's super simple to use it. Okay, you do not require any code change. You've seen that I've just, automatically traffic goes from one cloud to another one without having to change anything in the front end. That's great. Second, no network changes. It's level 7 communications. If your network allows network 7 or layer 7 communication, then it just works. And no admin privileges. Trust me, I'm not the administrator of these 2 clusters, but I was able to make them communicate. Why? Because everything is a layer 7 network and it's just a pod. If I can run a pod, that's fine. If I've got communication in layer 7, then I can do it. As you've seen, you can use the scupper. The scupper CLI tool for doing all this thing, all this service management, token management, link management, and so on. So with the scupper works, but also you've seen this console where you've been seeing. In this case, you see that it's a really complicated thing. In my case, it was just 2 clouds. If you've got 3, 4, 5 clouds, then it's more interesting to see. And also think that I will talk it later, but maybe some of you are asking, oh, it means that I need the scupper CLI for to run scupper, right? Yes, by default, but it also has scupper Kubernetes operator, which lets you install and manage all the scupper using YAML files. Okay, so it's GitOps friendly as well. Also, what I also have to offer us scupper? Well, with containers, we get it, portable. So we can move one container from one cloud to another one. That was great. We also make it object storage portable, right? It has been working. For example, there is a standard protocol for object storage, but network was something that was still not portable. But thanks to a scupper, now the network is portable as well, because we are in a layer 7 level. So we are abstracting from the network. So we do not care about IPv4, IPv6, or whatever. Doesn't matter. We've got scupper. As a developers, we'll send a request to the scupper service. That's all. What happens under the hood of a scupper is something that the scupper will do. It's protected. This is super important. Remember that only the service that we want are exposed, and those ones are encrypted using MTLS. And as I say here, basically, since it works at layer 7, we are skipping all the complexity of layer 3 security. This is one of the reasons why I love Scupper, because it's like, okay, I'm just using MTLS to communicate between services of different clusters, but without the complexity of layer 7. Of course, network is isolated. It means that you exactly decide, as I said, which services are exposed. It lets you hybrid cloud. It lets you do hybrid interconnections. So you can connect a virtual machine with, for example, OpenShift cluster, with a Kubernetes cluster in public cloud, and with, for example, bare metal computers or databases that is running on your on-prem data center. And you can interconnect all these different environments. And of course, as I said, all secure. Also, Scupper is smart enough to detect, as you've seen in the demo, when they need to reach another cloud or when they can run in the custom or in the remote cloud. Okay, and also is able to make this kind of, if this legacy application needs this on-prem database, it knows how to route the traffic to arrive to where you want it. Of course, if there is a failure, it can create or can find alternative paths. We've seen in the demo, right, that we've got this backend and we just stop the backend of one of the cloud, and then automatically the traffic was routed to another cloud. So it's great for high availability. And I also mentioned this, that it also finds the optional path to reach a destination in terms of cost and locality. So if there is something that is local in the cloud, then it uses this one. If not, it goes to another cloud. And if it has several options, it will always choose the one that is less expensive or it's cheaper. So thanks of Scupper, we've got connectivity between clouds. We've got the portability, because now network is, let's say, it's portable, right? You can just run Scupper in your, in your edge cloud, in your public cloud, in your on-prem cloud, and it doesn't matter which network uses each of these environments, because Scupper abstracts from this. And thanks of Scupper, you can start scaling up your workloads, because now you can have different clouds, or for example, one cloud with different regions, all of them interconnected, and also high availability. What's happening if I've got one service that is running in one cloud and this cloud goes down for any reason, automatically I can just go to another cloud and process the request. So you can see that you've got high availability as well. And that's all the things that I wanted to show you. I don't know if there is any question.
Alex, hello again. Thanks for your talk. So, let me fetch here your questions, because we have still some time left.
Yeah.
If you're ready, yeah, let's tackle the question. So, first one, when it comes to hybrid cloud, what are some common pitfalls or challenges that businesses face, and how can they avoid them?
Yeah, I think that one of the challenges is the data. So, of course, if you got the data in an on-prem database, then it's more or less easy. But what's happening when you say, hey, I want high availability for the databases, and I want to install a database in Amazon Cloud, and also the database in the Google Cloud. And I want to, get the data in both of the clouds all the time, because if one cloud goes down, I can have the other cloud up and running. So how can I manage this? And this, I will say that is the common pitfall. Then my recommendation is using some kind of database that is more, let's say, cloud friendly. For example, CockroachDB is a database that is really cloud friendly. So I will suggest you going to this direction. So the challenges always are with the estate. And that's the challenge, right? I mean, that you can also have this, for example, if you got a shopping cart, you will have the same problem. Then my recommendation is try to not or avoid a state if possible, and if not, then try to find some kind of cloud native approach for maintaining the state across the clouds.
All right, thank you, Alex. We got another question for you. How do you recommend that companies start integrating open source technologies like Kubernetes and native into their existing infrastructure? Any tips for managing the transition?
Yes, it's sometimes it's quite complicated, right? Because you're coming from one way of working, and then you want to go to another way of working, right? And then it's like, oh, how we can manage. My advice is never go with a big bang approach. So just start moving a step by a step. And my advice as well is starting, and it's related to the previous question, is start with stateless services. So services that do not have a state, because they are really easy to move. Because they have no state, no worries. You can scale up, scale down, move it to another cloud, more or less. Yeah, it's going to work. And if there is any problem, you can easily deploy another instance easily. If there is a state, yeah, then it's harder, because you might start wondering, have I lost data? Have I lost, I don't know, was this data really stored or not? Things like that, right? So for this transition, I would recommend you to go, first of all, with the stateless services, get confidence, and then move to, to the state or managing the state.
Step after step.
Yeah.
Perfect. Thank you, Alex. Next question. What specific features of Kubernetes, native, or Scupper make them ideal for hybrid cloud environments?
Yeah, I think that all of them works really good together. First of all, because Kubernetes is, let's say that it's the de facto platform for deploying nowadays, right? So it's really important to have Kubernetes. And then what's happened with Knative and Scupper? Well, they play really good, because if your concern is about the cost, see that in my application or in my example, I've got the backend in one cloud and the same backend running in another cloud. So I'm like duplicating the cost, right? So Knative, that is it's a serverless technology, lets you, for example, make the backend of the second cloud be with 0 instances. So no communication. So your cloud provider cannot bill you for something that you are not running. But what's happened if the backend of the first cloud goes down? Then the request will go to the second cloud, and since you're using Knative, which is a serverless technology, automatically will start this backend and process the request. So I think that all of them works really good together.
Right. Thanks for that insight. We got another question. Given the complexities of hybrid cloud, what kind of training or upskilling do you suggest for teams to keep them prepared for this change?
Yeah, this is a common question, right? And I always say the same, and we've been doing this in all the questions. The problem is always with the state. If you check the link that I shared with you, there is an example of creating a database across several cloud providers, and then all the data is automatically synchronized between all these databases. So I would say that it's searching, Googling a lot, because it's something that it's new, right? And for example, attending this talk, of course, and rewatching this talk, but then just Googling on how to keep data spread across clouds. As I said in the link that I shared with you, there you can find these kind of examples. But yeah, it's more like Googling, and especially take care of your data.
Right. Thank you. Next question for you. If a company is new to hybrid cloud, what steps should they take to ensure they have a solid foundation before diving into more advanced technologies?
Yes, I would say that the answer is I think it's quite simple. It's like, how much time it takes to you to deploy something to production? If it takes 10 minutes, then you are ready. No worries. If something goes wrong, you will fix it in 10 minutes. But if you're say, hey, I'm going to production and it takes like 6 hours, 8 hours, 12 hours, one day, right? Say, hey, let's go to production. And then you need to wait like one day until you see your changes on production. Then you've got other problems. We're just fixing this problem. And then when you are fixing this problem, then you will be able to go to this advanced, using these advanced technologies. At the end, it's like, going to the root of software development, right? It's like, I know how to develop software. I know how to deploy software. Now let's move forward, but not before that.
So yeah, thanks for giving advice also on that. We have another question for you, Alex. What are some key things to consider when balancing workloads between public cloud and on-premises servers?
Yes, well, I think that here it's a matter of the cost and the security. So yeah, at the end, if you're using the public cloud, it means that you're going to have an expensive bill because you're using their resources, not your resources. But at the same time, probably a public cloud might be more secure than your on-prem servers. Maybe not. I'm not saying that it's always this case, but it can happen, right? So it's just, the balance of cost, security. For example, also, if you want to start using some of the features that are offered by the public clouds, maybe you have your on-prem servers running, but you want to start using Amazon Lambdas. So then you need to decide, okay, I want to use Amazon Lambda, so you have no choice. You need to move to public cloud, right? So these are the key cases, the features that your public cloud offers, if you want to use them or not, and then the cost. I would say that this is the key things to consider. And of course, the knowledge that you've got with the public cloud. If you have just started using Amazon Cloud, then probably you will not start deploying quickly to Amazon Cloud all your workload, right? So of course there is a lot of things, but for me, it's the cost and the features that offers the cloud.
Makes sense to me, Alex. Thank you. And we got one more question. How do you see the role of IT teams changing with the rise of hybrid cloud and OS technologies? What new skills might we need to learn?
I will say that the skill is not a technical skill, is more but this is something that also affects to the developers, which is collaborate. They need to start collaborating because now I would say that all the devs and all the ops things is like in this gray zone, right? That is like, okay, it's all mixed. For example, with the Scupper, we're letting the developers create the hybrid cloud or the communication between hybrid cloud, right? So it's some things are moving from ops or from IT teams to developers, but probably developers, they are not well advised of all the details of the network, for example. So they still need the IT team. So I think that the transition should be more of a collaboration of listening each other, learning from each other, rather than learning some new technical skills.
Yes. Thank you, Alex. So before we close this session, maybe also to you, would you mind sharing a bit about your developer journey with the audience and me, like how you became first interested in tech and what were the steps that brought you?
It was like the previous speaker that I started when I was a child, but yeah, probably I'm older and I didn't start with the 286. I started with a Spectrum. Okay. So just with these cassettes and so on, right? So you started, but yeah, I started with 6-7 years old. I started then. I remember programming with BASIC, the basic of a Spectrum. But yeah, I mean, it was not programming; it was like copying programs in the magazines and in the books. And look, what's happening if I change this and things like that, right? So I started in this way, and then it comes the Intel or IBM era with the Intel chipsets, and then everything was easier. You start, programming these. I remember creating the BAT files for running games, so using with the memory. Say, hey, I'm going to, you get some kind of BAT files for running one game or another game, which gives you more low memory, high memory, and so on. So that was no. And then yeah, but I really start programming when the web comes. Basically, first of all, because you could learn from, you have resources to learn, and also you've got the HTML and JavaScript, which you can run it on your, in your own computer, in your browser, without needing a compiler or anything like that, right? So yeah, I think that was the journey.
Awesome. Then thank you so much for joining this and so many more things with us today, Alex. It was a pleasure having you. Thanks for the talk. Thanks for the Q&A. And hopefully we see each other again in another live day.
Sure. Thank you very much.
Alex,
Bye.
bye. Thank you. All right. And now we come to the final speaker of the day, Talia. But sadly, to time zone related issues, she couldn't make it live, but she sent us a recording of her talk, which is brought up now. Perfect. Then I would say,
hey everybody, welcome to
recording
Building
stage is yours.
Applications with Infrastructure as Code. My name's Talia Nasi, and let's go ahead and get started. So I am a lead developer advocate for Akamai Technologies, and my job is just to build things in the cloud, and then I talk and write about them. Before becoming a dev advocate, I was a test engineer, so I was responsible for QA, automation, testing, full like end-to-end tests, integration testing, all of the, basically every part of the testing cycle. Before Akamai, I was at AWS on the serverless team. Before that, I was at WeWork. I was a test engineer at Visa. So I've worked at some like pretty corporate companies. I've also worked at like smaller companies. And something that I want to talk about today is infrastructure as code, because it relates to a lot of different companies and a lot of different scales. You could be a small company, you could be a big company, but I want to go through an introduction to infrastructure as code and really understand the use cases and the why and what some of the benefits are, and then we'll talk about some tools, and then we'll go through a quick demo. So many times when developers start building applications in the cloud, they'll start in the console, right? So you choose the services you want and then you connect them. You build your Lambda function here, you choose what you want as a trigger for your Lambda function here, what do you want as your destination, you have maybe a database connected, maybe a server, and you can create like all the resources you need right there from the console. And this is a really great way to learn, right? Because you have this UI where you can see everything that you have in your application. The only problem comes when you want to move your resources to different accounts, or you want to move it from one environment to another, or just somehow like replicate what you've done in the console. So chances are you're not going to know exactly how you set up these resources in the first place and exactly which configurations you set. And so to solve this problem, we're going to look outside of the console to something called infrastructure as code. So with infrastructure as code, what you're doing is you're automating this provisioning process. So you're not going to go to the console, click on the services you want, configure the resources and everything from the UI, from your cloud provider. What you're going to do is you're going to create something called a configuration file where you define all the resources you want and all the configurations for those resources, and that's how you instantiate your infrastructure. So in this configuration file, you have one place with all of the steps and configuration for your application that you can reuse whenever you need. And the great part about this, and kind of the highlight of this, is that you treat your configuration files and your infrastructure as code. And so what are some of the things we do with code? We version it, we put it in a repo in GitHub or code commit or something like that. And then you deploy a version and you work on it, and then you merge a new version, and then you can roll back if you need to. So when you move into this new way of working with infrastructure as code, you treat your infrastructure the same way that you treat your code. So if something breaks and your infrastructure isn't working, you roll it back to a different version that was working, or you try a new version, or you can move it over here to another environment. You have this flexibility to build, change, and manage your infrastructure in a safe, consistent, and repeatable way. So why is this important? Like, why is building with infrastructure as code better than from a UI? So by using the same configuration files, you ensure consistency across these environments. And this takes care of that, well, hey, it works on my machine phenomenon. You have one source of truth, that's this configuration file. And this happened a lot when I was a test engineer. Like, I would see this all the time where I would open a bug, I would find something wrong, and I would, take a screenshot and write a defect report, and then I would send it over to the developers to say, hey, this is what's going on, and they would respond with, oh, well, it works on my machine. So this is something that you see a lot in the software development lifecycle between dev and QA. It's something that you see with customer success when they're trying to reproduce an issue that happens in production. So it happens a lot across many different teams, and this is one of the ways that we can combat that. It's also really great for onboarding developers. So like when a new developer joins your team and they're setting up their environment, let's say it's like their first day, and they get like this whole book of like, okay, this is how you set up your environment, and it's like 3,000 pages of like this deployment and that deployment, and you have to set up all these tools, and it's just really overwhelming. Versus when you're using infrastructure as code, all you have to do for the new developers joining your team is just give them the configuration file and say, hey, deploy this, done, like everyone's happy. Another benefit to infrastructure as code is that it eliminates configuration drift. So configuration drift happens when you have a shift in environment. So let's say there's an incident late one night, like really late, and there's an incident for your mobile application, and you look at the logs, you identify what the problem is, and in order to fix it, you need to update a specific configuration in production. So you make the change in production and you go back to sleep. Although you fixed the issue, you've just created an even bigger divide between your staging and production environments because you didn't make the same change in your staging environment. So many times staging environments are not the same as production because of changes made during incident management, and this is called configuration drift. So with infrastructure as code, rather than having that shift in environments, you have one central authority that is this configuration file, and then you just push the infrastructure changes through. It also decreases risk. So provisioning all of your infrastructure by hand really is risky. It requires a lot of manual work that's error prone. It might require like one single person to do, and like, what if that person leaves the company and they take all of that knowledge with them? So infrastructure as code really minimizes these risks. And so by representing infrastructure as code, you have these reproducible blocks of code, which are far less error prone because your infrastructure lives in a source code repository, and all of its history and its changes are visible to everyone on the team. So how do we actually implement infrastructure as code? I talked about this a little before with what we call configuration files, and we're going to talk about some of the tooling later, but one of the tools you can use is called Terraform. Terraform is an infrastructure as code tool that you can use for defining both cloud and on-prem resources in these configuration files. So I want to take a look at one of these configuration files as an example. So one of the most important things to note with configuration files is that they are declarative, meaning that they describe the end state of your infrastructure. So you don't need to write step-by-step instructions to create these resources because the infrastructure as code tool will handle that logic. So I don't have to go in and say, hey, create this IAM role and then click over here and go to this button and then click on, like, I don't need to say how to create these resources. All I have to do is list them in the configuration file, and you describe what, like, the overall topology, right? So when you deploy the configuration file, these resources are going to be either created if they're brand new resources, updated if they already exist, or deleted if you remove something from the configuration file. So in this example configuration file, we're saying, hello, please create this IAM role with these configurations, and please create this Lambda function with these configurations. Thank you, have a nice day. So I don't need to say how to create these resources. I don't need to give, the infrastructure as code tool, specific instructions or anything like that. Your cloud provider will handle this logic to create or update the resources that are in the configuration file. There is a core workflow for creating and managing this infrastructure, and there's basically 3 different commands. So the first thing we need to do is write the configuration file, and this is where you define all the resources. We just saw an example of this. You want to create all of the elements you need, and you do that with the command terraform refresh. And this will go out and talk to the different infrastructure providers. It's going to ask them what is currently out there, what's currently running, what's the current state, and it's going to this is where, like, the first step, right? Like, what is currently out there? Next, you're going to run an execution plan with the command terraform plan. And so in this stage, Terraform figures out what it needs to get your current configuration to the desired configuration. So let's say you write in your configuration file, I want to create this network on GCP, or I want to create this database on AWS, whatever it is. What you define in your configuration file, that's your desired configuration. When you run Terraform plan, Terraform says, in order for me to execute this plan and make your desired configuration the actual configuration, this is what I need to do. I need to create this resource. I need to update this resource. It's the execution plan. It's basically, think of it as like a diff, like a git diff of like the differences between what's existing now and what you want to update. And then we have Terraform apply. This is where Terraform performs all of the proposed operations and executes the plan. It figures out what the right order is to create all the resources, and it executes that plan. So it makes your desired configuration the actual configuration. And there's a couple of parts to Terraform that are essential to the way it works. So first we have Terraform core, and core is responsible for a few things. It takes in that configuration file, again, which is provided by us, the user. It also takes in the current state, and this current state acts as the source of truth for our environment. Terraform uses the state file to determine the changes that we're going to make to our infrastructure so that it'll match our configuration. And this state file maps real-world resources to our configuration. It keeps track of things like metadata. Core is also responsible for how different pieces relate to each other. And then on the back side, we have providers. And providers are how Terraform connects to the rest of the world. And these could be cloud providers like AWS, Google, Azure, Linode, Akamai. They could be on-prem infrastructure like VMware. They could also be platform as a service tools like Heroku or Kubernetes. Other things Terraform could manage are software as a service. So there's also like very high level things like monitoring with like Splunk and source control with GitHub. And these are all externally managed services, but what's great about Terraform is that it understands that all of these pieces are related and all these pieces are connected. And so you have all these pieces of important infrastructure, and you can't deliver your application without your infrastructure as a service, your platform as a service, your software as a service. They're all part of your logical end-to-end delivery. And when you use an infrastructure as code tool, you get this single unified delivery of all of these components. And me as a developer, like, I don't want to have I don't want to have to use one tool for my infrastructure, one tool for my observability, and one tool for every service that I add to my application. I don't want to have to like piece together all of these things. Instead, I want one place where I can have a holistic view of my application and what's going on all sides. So let's talk about kind of the adaptation of infrastructure as code. So let's talk about how do you start? So on day one, you go from running nothing to running something. And this is where you provision your initial set of infrastructure and you describe what your desired configuration is. So when you run Terraform refresh says, hey, there's nothing existing. And then when you run Terraform plan is going to create that execution, and then apply is going to go out and create everything for you because, again, this is day one, there's nothing there. Then there's the more challenging day 2+, and this is where you have your existing set of infrastructure and you're trying to evolve it, you're changing it over time, you're adding new services, you have existing infrastructure and you enhance it by adding these other elements, and you rerun that exact same workflow. Now, there's many moving pieces to infrastructure. Maybe one day you have a Lambda function. Maybe one day you add a database. Maybe one day you remove that database. Maybe one day you add a server. So you can imagine, like, over time, your infrastructure is going to expand and evolve, and you'll likely add different pieces. You're going to add more complexity, decrease complexity. And you have this process that you can use that's not going to change no matter where you are in the evolution of your life cycle. So then on day N, maybe in the future you decommission your infrastructure. Maybe these resources were for a test environment, or for some reason you don't need that infrastructure anymore. You can remove them with Terraform destroy, which is basically a specialized version of apply that will talk to those providers and destroy those elements. So there's many advantages to this workflow. What's great about Terraform is that your day one experience is identical to day two, right? So it's something that you're going to keep doing, you're going to keep evolving, but you don't need separate processes for each stage of development. Another advantage is on day N, where maybe you don't need this infrastructure anymore. You have the option to destroy, which cleans up your environment. And so in this life cycle, you go from running nothing to running something, and you evolve this day over day, and then you can decommission it. So as your team grows, it can be challenging to manage your infrastructure. And so normally companies will start with a single individual practitioner who's creating this configuration file locally, right? Like there's one person, they're like the DevOps person, and their workflow will start with writing some Terraform configuration. And then they'll go through that process that we talked about, and it's one person, and they're going to continue to evolve that infrastructure by themselves. And now, what if you go from running from a single individual to now there's like multiple teams? Maybe now you have like a DevOps team, and other people want to collaborate on managing the same infrastructure. So how do we make sure we have a consistent view of what the current configuration is and make sure we don't step on each other's toes, right? Because we're going to be making multiple changes in parallel. And what we do is there's something called Terraform Enterprise, which you still write your configuration and you plan it locally, but now you push your plan into a version control system, something like Bitbucket or GitHub. Basically, you move this to a central repository where you're managing this and you're coordinating the changes. And then your company does really, really well, and maybe you have a lot of teams that are working on your infrastructure. And so there's people who don't necessarily need to know about all the parts of your infrastructure. Like maybe there's new developers, or maybe there's like, I don't know, some business people who don't need to know every configuration for every piece of infrastructure. So what you can do is use something called a module. And a module is like a black box of infrastructure. And what happens is you define a set of input variables that let you toggle the behavior of the module. And the module might emit a set of output variables. So basically it's a container for multiple resources that are used together, and they can be used to create lightweight abstractions so that you can describe your infrastructure in terms of its architecture rather than in terms of its physical objects. So basically you can manage a group of related resources as if they were a single resource. And what you're doing here is you're encapsulating the complexity and you're making it more accessible to a broader audience, because a developer might not need to know all of the details of every part of your infrastructure or of one specific part. And even for if you're following the principle of least privilege, it might be better for some people to use this module. Now, how do we manage all of these modules? Well, something that you can do is publish them to a central repository, and there is a central repository that exists today, and it's called the Terraform registry. So if you go to registry.terraform.io, it's the global public registry, and you're going to find common forms of infrastructure, common architectural patterns, and what's great about this is that most of them are published by the cloud providers themselves, and it just makes it so much more consumable for us to go in and, I don't have to know every detail of how to create a Lambda function and everything that happens in the backend. I can just go into the registry, type in Lambda function, and find the code that I need and copy and paste it into my registry. So I can go in and say, I want this network from Google and fill in a few of the inputs that matter, and then let the module take care of the complexity. Another benefit of using Terraform is that you can do multi-cloud deployment. And nowadays, I think it's very rare that companies are using only one cloud provider. So one of the benefits of this, when you provision your infrastructure across multiple clouds, is that it increases fault tolerance. You have more graceful recovery if one cloud provider has an outage. And it also simplifies the management and orchestration of these infrastructures when you're using a tool like Terraform. So just another benefit. So I just quickly want to recap before we get into the tools. Infrastructure as code, why do we use it? Why is it beneficial? What are the advantages? So first, it enables everyone to be able to self-service their infrastructure regardless of your DevOps experience. You can implement the principle of least privilege, and use modules for people who don't necessarily need to know all the physical details of the infrastructure. You also get this natural progression from day 1 to day 2 plus to day n, and you don't need to change a lot about the existing processes. When you use infrastructure as code, you get this single unified delivery of all of your infrastructure as a service, platform as a service, software as a service components. And again, I don't want to have to use one tool for my infrastructure, one tool for my observability, and one tool for every service that I add to my application. I have this one single unified delivery of all of these components, and I get this really holistic view of what's happening in my application. You can import your existing infrastructure if you didn't start building with this. You can do multi-cloud deployments. You can also optimize your cloud costs. There's a lot of stuff on pricing I know Terraform just changed their pricing, but it is an open source tool that you can go in and start using. Okay, let's talk about tools. So there's so many choices when it comes to infrastructure as code tools. We talked about Terraform a little bit. One of the differences between Terraform and the other tools that I talked about is that Terraform allows for multi-cloud deployment. So you can deploy a database with GCP and an instance from Linode all in the same configuration file. They also have a registry with pre-made resources that's written in the correct language for those configuration files. AWS has two different infrastructure as code tools. There's CloudFormation, which is used for non-serverless resources, things like EC2, RDS. And then the second one is SAM, the serverless application model, which is used for serverless resources. And these are things like Lambda functions, DynamoDB tables, SQS queues. One of the biggest differences between Terraform and CloudFormation and SAM is that in your AWS configuration files, you can only add AWS resources, whereas with Terraform, you can have more than one cloud provider's resources. So if your entire stack is on AWS, then yes, you should use an AWS infrastructure as code tool. AWS configuration files are written in either YAML or JSON. Google Cloud is another cloud provider you can use. They also have templates. They also have an integration with Terraform. You can use a scripting language like PowerShell, and PowerShell has something called the PowerShell Gallery, which is a central repository for sharing and acquiring PowerShell code, and you can add resources from other cloud providers as well, so that's a plus. So some things, and then, there's also Ansible, which is more of like orchestration, which you can use with Terraform. So, you can use different tools for different parts of your infrastructure if that's something that you want to do. So some things to think about when you're choosing an infrastructure as code tool. Are you using services specific to that cloud provider or external services as well? And do you want your configuration file written in YAML or JSON or a scripting language like PowerShell? Are you doing multi-cloud deployment? Things like that. And the most important thing to take away here is that it doesn't matter what tools you're using to provision and configure your infrastructure. I just want you to capture this process in a way that can be repeated and automated, and that's going to make your life a little bit easier. So let's go through a quick demo. I want to do this with a Linode Terraform provider. So the first thing we have to do is you need to have a Linode account and you need to install Terraform. I'm gonna post the QR code to this at the end so that you can go in and create a Linode account and install Terraform. It'll go through everything for you. So if you don't have an account, you can create one for free and then you can install Terraform. It's an open source tool. So the first thing you have to do is generate an SSH key, and this is how you connect to the server. And you use the command SSH keygen. And then you have to copy your SSH key, copy it and save it because we're going to add it to our configuration file. Next, from your Linode account, you need to create a Linode API token. From your profile, choose create a personal access token, choose the access levels, and then again, copy this because you're going to have to put it in your configuration file. So next, we need to create your configuration file and save it as a .tf file, and that's how Terraform knows what to look at. So the easiest way to do this is to type nano in the file name, and then you're going to insert your API token, you're going to insert your SSH key, those are the two that you just created, and then you're going to enter your root password. So the resource that we're creating here, this is a Linode instance, and we're calling this Terraform Web Example, and you can see these are the configurations that we're using. We're saying this is the region, this is the type of instance. At the top of the page, you can see that we're using the Linode provider from Terraform. This is all from the Terraform registry. And again, you can copy and paste this from the Terraform registry. So once we deploy this, we're going to see this Terraform Web Example inside of our UI. Next, we run Terraform init, which is going to initialize Terraform. Next, we run Terraform plan, which is going to create that execution plan. So what's the difference between what's currently in production versus what I'm trying to update? Next, we run Terraform apply, and it's going to apply our changes for us. And then once we log into Linode, we're gonna see this Terraform web example created. So this is just a very simple example of building your infrastructure with Linode and Terraform. Again, here's the QR code where you can go in. If you have not used the Terraform registry, I highly recommend. It's registry.terraform.io. There's so many different providers, so many different resources from different providers that you can use. And you can use Linode for those cloud resources. We do have a free version, so there's also some more resources you can use on YouTube. If you go to youtube.com/Linode, we have a great DevOps community, linode.com/blog. Terraform, again, is an open source project you can contribute to. This is my Twitter account at Talia_Nasi. I also just created a blog and a website. It's called buildwithtalia.com. Thank you all for joining, and please reach out on Twitter if you guys have questions or comments, and have a great day.
All right, thanks to Talia for sending us this talk. If you want to rewatch it or any of today's talks, they will be on our platform on Friday, but you will get an email on this, of course. And yeah, now with that concludes our Cloud Day, today's event. Thank you all for joining. Just some more information. Now that the event is over, go to code100.dev if you are in Manchester on May 22nd, because you will get a free ticket on us, have a nice coding competition and a nice after work. Or if you're up for the competition, you could also apply as a challenger yourself, and maybe you will be our next local Code 100 champion. Good luck on that. And yeah, we see each other on May the 8th, when it's all about security. So thanks for joining and see you soon. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.